Good morning, distinguished resource person, Principal, National PG College, Professor Deven Kumar Singh sir, Professor Ram Krishna sir, Head Hindi Department, research scholars and all participants. We are here on the third day of our AICTE sponsored Advanced FDP program on harnessing the digital revolution for business, education, and societal sustainability. As we move into a fifth session of the FDP, we now turn our attention to one of the most informative forces reshaping global industry today: intelligent automation, connected system, and robotics in industry, which we can say in common sense, common language, industrial revolution. From the self-optimizing production, supply chain, linings, and collaborative, seamless human efforts, this revolution is redefining what manufacturing and efficiency means in 21st century. And there could be no better guide to talk on this topic through this landscape, our subject expert, Dr. Ravi Prakash Verma. It's my privilege to introduce to you Dr. Ravi Prakash Verma, a name that needs no introduction to many in this room, given his long-standing association with academic excellence in computer science and artificial intelligence. May I request Professor Deven Kumar Singh sir to kindly felicitate Dr. Ravi Prakash Verma sir with the memento as a token of our gratitude and respect. मैं प्रोफेसर राम कृष्ण सर से भी निवेदन करना चाहूंगा कि वो रवि प्रकाश सर को प्लांट थैंक यू सो मच सर। मैं महाविद्यालय के प्राचार्य प्रोफेसर देवेंद्र कुमार सिंह सर से निवेदन करूंगा कि वो आज के विषय आर्टिफिशियल इंटेलिजेंस, ऑटोमेशन पर अपने 2 शब्द से हमें अनुरोध करें।
बोलने के लिए तो आप बोलेंगे, क्या बोलेंगे
सर जैसा आप कहें। ओके, डॉक्टर रवि प्रकाश वर्मा सर इंडस्ट्री में 24 साल से ज्यादा का अनुभव लेकर आते हैं। He is currently serving as Professor and Head, Department of Artificial Intelligence and Data Science, IIMT College of Engineering, Noida. Over the years, he has held distinguished academic and leadership positions at institutions like ABES Ghaziabad, BBD University, Integral University, Rama University, Ambalika College, Lucknow, and many others. A prolific researcher, Dr. Verma has authored numerous publications including Scopus Indexed and IEEE journals. He edited academic books, published various chapters in books. What makes today's session even more special is that this is not Dr. Verma's first engagement with National PG College. He has previously conducted a session, and let me clarify, it was a wonderful session on ethical application of AI in research during our earlier basic ATAL FDP program in 2024. We are therefore delighted to welcome him back to our campus may request Dr. Ravi Prakash Verma sir to enlighten us on Industry 4.0, Smart Factories and Robotics, which is our topic for the session. Sir, please.
बैठो तिवारी जी आप
Good morning, everybody.
Good morning, sir.
And I'm very delighted and I'm very honored. And it's been privilege while taking session in National PG College, because I've been twice invited in the ATAL FDP program. And as if you remember my previous session, now I worked very hard to keep things simple and easy for us, so that we can have a better understanding of what is going on in Industry 4.0 and in robotics. Okay, so we'll keep things very light. Okay, and wherever you feel like some doubt or query, you can inject yourself in the discussion itself, and please be attentive, because I have a habit of keeping my audience engaged. So be attentive, and let's begin with the session. Okay, so Industry 4.0, so and smart, and that means smart factories and robotics. So we are a developing country. Some parts of India have been developed to a scale of they match the world class infrastructures. But if you talk about country as a whole, so country lags. Okay, so there are two sides of the coin. One is we have poor India, and other is very developed and high-tech India. Okay, so the Industry 4.0 is actually something which have been imported from West. Okay, but the experts agree that if you want to foster ourselves into some developed league of nations, so we should have Industry 4.0. So those students, teachers, and others who are planning to actually do something in needs to manufacture or helping the students for startup, you have to actually keep Industry 4.0 standard in your mind. Okay, and robotics. It does not mean that how cheap labor is available in your locality, but to match the global standards, you have to actually work with robotics and Industry 4.0. So let's begin. So the agenda would be introduction, industry evolution, core technologies, smart factories, robotics, case studies and research discussion. Hands-on activities are there, but I'll try to reach on the hands-on activities. But if not possible, then all the above mentioned topics are self-sufficient. So our learning objective would be understanding Industry 4.0, exploring the smart manufacturing, learn robotics and integration, and realizing the real-world applications. So we all know that fourth industrial revolution is all about physical production system with digital technologies, and the key drivers are artificial intelligence, Internet of Things, big data analytics, and cyber physical systems. Okay, And there have been many evolutions. We will be covering all of them. Yeah, we will be covering all of them. And it focuses on real-time discussions, decision making, and autonomous or in machines. So digital transformer of manufacturing means smart factories. Smart factories means where the system, machine, the expected output, and the humans, workers, are all interconnected. Machine understands human, humans understand machines. Okay, that is a smart factory. Now, production processes are enhanced to real-time data collection, predictive maintenance, automation with intelligence robots, cloud and edge computing. And this leads to efficiency and production quality, flexibility, decision making, and innovation. You take about any aspect of managing production, Industry 4.0, okay, and smart factories are able to do so. Let's see how. So we have we are in fourth revolution. So first revolution was steam. Earlier, whatever the industry used to operate, they used to operate on the manual work. There is a set of laborers coming in, working with small tools of machines, and there is no automatic process. Then steam engines came into the existence, and a steam engine actually moved the pulleys and the wheels of industry. Okay, and then we have that big revolution. We had mainly textiles and other things available at a cheaper rate. Then we have Industry 2.0. Since steam was causing problems like pollution, accumulation of coal, okay, burning of fossil fuels. So electricity was much cheaper, very efficient, less noisy, and easy to handle. Okay, so in Industry 1.0, we had a steam engine. That means basically a set of boilers. Boilers used to drive the engines, and then your production used to take place. So there were three sets of problems for that: managing the fuel for the boiler, managing the steam engine, steam production, and then you have to manage your own production and machines. So this was reduced with the help of electricity. You can establish your industry anywhere because electricity is readily available and easily available, accessible. So you have to just focus on your machines which are producing. Then 3.0 is all about automation. So everything was automatic, and that also helped us a lot. And then was 4.0 means digitalization. So we will be covering digitalization more. So let's see this graphics. It was started in 18th century, steam engine introduction. Okay, so this basically transformed the production. Then till late 18th century, okay, you have mechanized manufacturing. So the output was textile and iron growth. Okay, so both these two industries flourished, and that was the basic demand of that era. Then in late 18th century, electricity revolutionized everything. Assembly lines and innovation was made. Okay, so for example, Ford's assembly line for Model T. Okay, so Henry Ford came up with the production of cars, and mass production was achieved because electric power and assembly lines were able to produce the parts and machinery at a very fast rate. And in fact, Henry Ford has a vision that everybody on this planet should have its own personal car. Okay, so that was his motto. Now we have Industry 3.0. So we have automation, we have introduction of computers, PLCs, programmable logical controllers, robotics in manufacturing. And so in late 20th century, we were able to do repetitive tasks. Okay, a task which is repetitive, and the efficiency increased, the production increased, the cost of the production came down. And then we have precision and consistency, because machines are doing something, so things would be very precise. Okay, like manufacturing prototype. So we have a boiler plate. That boiler plate means we have a die that is manufacturing. Something is being manufactured within that die. So you see for example, your cup of tea, they are of same size because it is made from the die. No humans are not directly making that cup of tea. Machines are doing for you. So every cup is precise of same size, have same volume, and so on. So production is fast, and that is why it is very cheap. You use it once and throw it off. Okay, no need to wash it again. Utensils. You remember having tea on in a cup, in a small glass. Okay, at tea shop. So they used to be washed and washed. So very few people used to visit that tea shop because people had a hygiene issues. Okay, because the glasses were not properly washed. Now you can, if somebody offers a tea at that stall, you can you would easily accept that invitation because you know it would be served in some disposable material or utensil. So hygiene is not an issue. Now we have industry 4.0. So this is a very complex structure. So don't worry, I'll be taking each part one by one, and in some of the slides you'll see that something is common, means common. So that common helps you to make association in your mind that what is going on. So if I talk about industry 4.0, there are 5 things. First is integration of technologies. That is, you have AI, you have IoT, you have cloud, okay, and you have big data. So 4 major means technologies are there. And in real-time monitoring, because IoT devices are collecting data, okay, and data analysis is being performed regularly, repeatedly, without human intervention. Okay, so that gives you the data analysis part. Then with that data analysis, you can make decisions. You have strategic choices, market responsiveness. Okay, so you can respond to the market very easily. And we have smart factories. Those are basically cyber physical systems and with lots of things automated. Now, this gives us self-optimization. That means process improvement and efficiency gain in the total production chain. Clear? I hope there isn't any doubt. So this is a complete picture which we will be discussing today in Industry 4.0. Okay. Now, let's start with the basic things. Now, things are connected. Things are connected. For example, if a machine is making a production, okay, suppose you have a simple drop-out example of machine. Imagine fan. You have ceiling fans in your college, and each ceiling fan is communicating with a central server about its health. Okay, and since the data is being continuously received by the central server, it can keep an eye that which fan needs maintenance, so that before things go out of hand, somebody can come, take that fan off from the system, repair it, grease it properly, and then put it again, install it again. So things never break down, and this preventive maintenance can be done after the classes, so nobody gets disturbed, no complaints in the system, the fan is not working. So this kind of things are there in the real industry. So, and that can only happen with the basic thing that if machines communicate, okay? And then the automation executes the task. So if machines can communicate, we can monitor their health and we can automate things. And intelligent devices, drivers, smart decisions making in Industry 4.0. So we have machines, automated systems, devices, and sensors and people. So we have machines, devices, sensors, and people, 4 components. And that 4 component gives us integrated manufacturing environment, seamless connected production system for enhanced efficiency. So we have better efficiency. Imagine a scenario, a company is producing something, some item, let's say something, And for example, pen, it is being produced by the machine, and all of a sudden on one fine day machine breaks, it halts. So entire factory sits idle because machine is out of order, and in that situation you have to call a mechanic for repairs. Repair will take its own time, and till that time your entire production is halted. You incur losses, you are out of the competition day by day, hour by hour, because somebody else is actually fulfilling that gap, because your production is not in the market. But if that machine is able to communicate to the person that, okay, I am not fine, I need repair and maintenance, okay, so that will help us to actually better manage the production system. Oh, okay. Integration of physical and digital. So we have physical machines that is working with tangible components. Then we have digital technologies, software and computing elements, sensors, devices that gather real-world informations, computer systems and software and computer systems, brain that processes the data and controls the machine, hardware and software interaction is there, and then it results into smart factories and industry 4.0, the application and future of CSPs. Okay, so this is how it moves: physical machine, digital technology, sensors, softwares, and hardware software interaction takes place, and then finally you have a smart factory. So you move from in a clockwise direction and you get a smart factory. So these are the basic things that will happen, and they are happening actually. So real world interaction cycle, how it happens? So we have a data exchange, that means continuous flow of data is there. We have monitoring and analysis. These are automated systems which are monitoring entire factory. Then we have instant response to problems. Okay, so your response team can actually suggest pre-propose some solution for some problems which are frequently occurring. And then you have decision making and automation. So this is the cycle how industry is actually maintained. Let it be any industry. So this is how it be maintained. So now I've talked about 5 components. The first component is IoT. IoT means that there is a device, it has some function, it has some presence in the environment, but it has one more feature, that it is connected, it can pass on its data and receive the commands also. So that's it, basically Internet of Things. You have a smartwatch that is actually monitoring the number of steps you walk today. Okay, and if you send that data, you want to send that data from smartwatch to some cloud, you can easily do that. You can receive communications, you can check your emails, you can have messages. So that is smartwatch. It's a wearable device. Similarly, if a machine is making something, so you know, machine which is engaged in production will have moving parts. So if a machine is going out of order, so all of a sudden the vibrations will increase. There are we are lucky we have person from mechanical and electrical department. Sir can easily understand that things in mechanical means motion, rotatory revolutionary motions controlled by electricity. So if something is going out of some bearing or some bush is out of order, so all of a sudden sound will increase. Now the sound sensor, which is actually continuously recording the machine sound, can suggest, can record, can measure the smallest change in the vibrations, and that is being sent to the software for analysis. Software filters out what the problem is. It can even locate where the problem is. In IIT Kanpur, in way back in 1994, so there was a student who was working on preventive maintenance. So he identified, he recorded the various sounds of the moving parts of the machine, assembled the entire machine, and then he can figure it out that which part is actually will go out of order first. Clear? Because acoustics were being analyzed. So this is how you can do. So what happens is that we have an IoT device ecosystem is, we have a wireless network, smart homes, connected cars, industrial machines, wearable devices, and cloud platform. So data from all the devices comes to cloud platform through wireless networks. And on the cloud, we can keep the intelligent softwares which are actually monitoring the device data. Clear? Suppose if I give everybody a smartwatch with some program installed in it, and your principal calls up in the afternoon that, sir or madam, you have not even taken 100 steps today. Please, it is mandatory for college that you take 500 steps. Go to the park and walk and come back. So that your health, your body functions properly, you do not take CLs, okay, you never fall sick. So that is what a preventive maintenance. Similarly can be applied to machines also. So now we have big data analytics. It's a very big topic, but things in a simple way. We have data ingestion, that somebody is collecting the data. Data is collected over here in this. Now data is processed. The collected data, let's say 100% is there. After pre-processing, you have 80% of the data. Then you analyze the data. That means you have 60% of the data. So every step you are removing 20% of the data. Now we have data analysis, and from that data analysis, only 40% of the data will be used for making a decision. So this is how big data or data analytics works. So this inverted pyramid shows that the amount of data is received on the top, then it is being reduced to every step at 20%. This is the, as per the stats suggest us. Now cloud computing. See, cloud computing is nothing. We have a set of connected devices which can remotely access. We have a cloud storage that no need to bother where your files are. And then we can do data processing. So cloud has one advantage. You keep your files in your laptop. What happens if your laptop is out of order? Okay, so those who have recently purchased a laptop, they say that when you log into your system, it asks for Microsoft ID. Okay, OneDrive. So whatever files you make are automatically shipped to the cloud platform. Your hardware goes out of order, do not worry, throw it off. Your data is intact in the cloud. As soon as you log into the new hardware with the same ID, you can pull down your data. So this is the advantage of cloud. No need to worry about your data backups, everything is intact. Whatever you have created, it is there. Employee comes and leaves. Whatever work he or she has done is retained with the organization. No need to ask for that where the file is, what is the name of the file, file has been corrupted, file not found. These issues are all together taken with the help of cloud. Okay, simple. In simple terms, cloud. Now artificial intelligence, the word is talking about it. So artificial intelligence or machine learning is nothing. If you have the data, you can pull out some numbers, you can put analysis, you can do some analysis on that number, draw some decisions and conclusion, and that is what artificial intelligence is all about. So what you need is data nodes which can actually provide the data. Okay, then what you can do, you can apply your machine learning algorithms. Okay, what you can do, you can prepare charts and graphs, and you can make predictive system which will predict. If you have traveled to the Volvo bus, okay, in computers, if you open your power on your desktop, there is one message it comes like post. What is the meaning of post? Can somebody tell? Because most of them must be from the computer science background.
Power on self-test.
Yeah, power on self-test. If you travel to Volvo bus, as soon as you put on your ignition, it also do the post test. If something is out of order, the Volvo bus would not even move an inch, and that is why people trust to travel in Volvo. that you are traveling from Lucknow to, let's say, Delhi, so your bus will not be down, okay, somewhere in between. It will be on the station itself, it will refuse to start. So that is the technology in Mercedes-Benz and Volvo buses. Clear? Your new cars, new age cars, they also do all kinds of post test. If you are less on the engine oil, they will not start. They start give you warning. Okay? Clear? So this is what post is there. Means it is you are working with them, you are riding on them, but you never come to know what their means true utility. So these are actually using some kind of algorithm, and those kinds of algorithm are not basically the pure machine learning algorithm, they are proprietary algorithm of that organization. Okay, and but they are working as a predictive systems. They tell that yeah, we can take 500 kilometers of ride on this bus or in this car, nothing will happen. Okay, and in Scorpio they can also analyze the tire pressures. If your 3-4 tires are there, one tire is less on pressure, it will give you warning. The tire number 3 is having less air pressure. So you don't have to actually, earlier people used to, before starting the car, they used to kick their tires, every tire. So they used to take a round around the cars, okay, to inspect the tires. You sit in the chair, the system will tell you that what is the condition of your tire, your fuel, oil status, your radiator status. So the things are improving. Now we have a digital twins. Now the concept of digital twin is that whatever the physical machine that is available, we have a physical twin. I mean, a physical machine is there, we have a digital twin. Digital twins means that as machine is working, it is taking some data, it is doing something, it is making some product. In the same way, in the cyber world, its digital twin is existing. That can keep monitor that how many units it has produced, what it has done. Okay, it means it's all about controlling software. You do not have to actually physically go there and count the number of items produced. The machine, the digital twin is telling you on your laptops and desktop that how many parts it has produced, how many product it has produced, what is the efficiency rate, what is the health of our machine is, some repair or maintenance is required. That can also be forecasted early. Okay, and on the longer run, you have some, let's say 10 units doing the same work. The system can monitor that unit number 4 and 5 will go out of order very soon. They require maintenance. So this is what integration of IoT, the physical machine, IoT, cloud, AI. So 3 things are working in a unison to give you a digital twin. So a virtual digital model acts as an analytical counterpart that processes the data to simulate and predict behaviors, consumes incoming data, streams to maintain an accurate and synchronized state. Okay, you are manufacturing a small part. So earlier, if you go to Kanpur and other industrialized towns, this plastic glass, if you go to purchase it from retailer, it is available that 50 rupees per piece for a packet, and a packet has 20 pieces or 25 pieces. So hardly the cost is around 1 rupees. Clear? But the wholesaler is purchasing, yes.
Sir, digital twin is only for monitoring or controlling also?
See, the thing is, if you can monitor, you can control.
Like we can give command over there.
Yeah, you can command, you can shut down. I'll give you an example. You remember the era of CDs, Moser Bear, CDs, okay? Still, if you visit some industry in Surat, the cloth is being produced and it is in lengths, and it undergoes with many motors, with many processes. If one motor is out of order, the next motor I think it's low on battery. So if one motor is out of order, the other motor will pull that cloth and entire, yarn, your entire cloth sheet will waste. And to actually start and stop that entire line of length of cloth production, okay, you need a very good electrical engineers, good softwares which will stop every 400 or 500 motors, and each motor with certain gears is moving with certain velocity, okay, because let's say in this part your cloth needs to spend 15 minutes in a machine, 5 minutes in a machine, and at some other speed, some other machine, the same which is being processing the cloth, the cloth needs to still stand at 3 seconds. So there is a differential of 2 seconds. So that is being maintained. That is why if you have a picture of old movies, so you see that cloth is moving up, coming down. So this is all being controlled with the time delay. It's a time delay. Clear? So controlling is also there, and your monitoring is also there. Clear? So that is how it is being served. But earlier we had very limited machines that can actually be controlled through software. Now every machine has its own digital twin. You buy a physical machine that will do work for you, and you have a counterpart software. Through which software you can control the machine. Okay, no need to do so. Tata Power company, Tata Power. So they are supplying, it's into distribution mostly. They have, I was working in BBD, so I had made a software for them, which is actually taking latitude and longitude, and through latitude and longitude, it is calculating the sunset time and sunrise time. And through sunset and sunrise, they control the on-off of their power. Okay, our simple UP State Electricity Board, their tube lights is on still in the day. You must have seen earlier. Now you hardly see that light is on in the day. Now how it is possible? It is because the machines have improved, not the UP Power Corporation has improved. They are operating on same thing. What are they doing? They are started putting the intelligence systems. Clear? And through one switch, at some engineer at Tata Power can shut down the entire electricity of the town or a city or any area. They can control the transformer. Each transformer installed by Tata Power communicates to Tata Power centers that what is my temperature, what is the input load, what is the output, how much current has been drawn, I am under load or I am overload. And that is why the UP states electricity transformers, they go out of order in summers. Transformer jal gaya. Clear? But if that same situation, Tata Power's transformer is there, it informs the center, shut me down or else I'll go out of order. So they shut it down. Once the temperature, there is a cooling oil inside the transformer, temperature is brought down, they again start the power. Okay? So that is how things do. Okay? So smart sensors is very important, because sensors collect data from the environment and they send it to, next step is that data is sent to central systems. Okay? And then real-time monitoring of collected data happens. So this is the software. Okay? Now this sensor is actually collecting data from the machine. Once it comes to this software, you can do real-time monitoring and you can do the controls. Clear? Now we have interoperability. That means machines communicate with each other. Means two machines of same kind can communicate. And that happens because we have HTTP, MQTT, okay, and TCP/IP protocols. Now the industry standard is MQTT. It is MQTT. Okay. So you have heard about mosquito? if you can install that mosquito software, so you can put it in your devices, and that device can control, they can send that data to the central server, and from the central server you can actually monitor the device. So you can make any device to communicate. And but you can also do communication with HTTP and TCP IP, but for that what will happen is that you have to actually write proprietary softwares at device level, so which is very hectic. Okay, with the help of MQTT you can install it, and it roughly takes care of every devices. Now we have applications, IoT based application, industrial automation, smart cities. These are these are actually a type of applications. And we have machine communication and technologies. The technologies which are supporting this: wireless, wired and Bluetooth. This is how the machines communicate with each other. Okay? That means two Volvo bus or Mercedes Benz bus can say hello among themselves. Okay? They can communicate, they can pass the data. Clear? Sorry. Yeah. Now, with this help of communication, we can have decentralization. Decentralization means no single fellow, no single person, no single maintenance hub, workshop can actually take major decisions about maintaining a device. Okay, suppose a bus has been broken down, let's say in a very small city, and it is en route with this UP Roadways Corporation. A small mechanic which is not fully trained, okay, can do repairs because somebody at remote site will be helping, assisting him. Clear? This assistance is being given to them. Clear? If you buy a BMW car and if it breaks down, every BMW car is connected to BMW's own private satellite communication network. So they will provide the support on the site, and this all happens because of one thing: communication, because they can communicate. So we can have a decentralized system which is have distributed control, shared responsibility and collaborative management. Okay, and this is all happening through network connections, interconnected system, or with the help of communication channels. The independent systems means multiple entries, independent operations, and autonomous decisions can lead to self-governance, no central authority. And this is what decentralization helps us. Okay, clear? So that means, to more relevant example, a doctor in a small CHC center, okay, can help a patient if he is connected to some expert at major city. Okay, he can pass on the symptoms of the patient to that expert. The expert will say that no, the patient is undergoing a heart attack. You do this, you do this. So at least the life of the patient can be saved. So that means there is no central agency. Everything is decentralized. You can take small steps which lead to major impact. Okay, which leads to the major impact on your system overall. Now, and what will happen if everything is decentralized? Instant data processing. Next step is what? If you have everything decentralized, we have instant data processing. Now, real-time analysis is there. Immediate insight is being provided because real-time data is collected. So we have speed. We have a speed, precise interpretation, and informed decision leads to accuracy. So, and how the efficiency improves because instant data processing is there. So your overall system is very efficient. Clear? Now, this helps in resource optimization, reduces the cost. Clear? Got it? Those who know the AKTU system, so earlier they used to send the question paper to post office. No, earlier they used to send the question paper before the start of the examination to all the colleges. Once it is being reached to all the colleges in UP, day 1 maths paper first will happen in first shift. Now they started using post office for that service because of communication. Now they mail to every examination controller of college, so everything is decentralized. So what has happens? Overall efficiency is increased. Okay, and speed is there. Now if there is some problem in the question paper, you can communicate onto that channel and the solution can come. So we have overall speed, efficiency, okay, and accuracy. So similarly, if machines have been connected on real-time data, insight is there, you have precise interpretation of data, so resource optimization and cost reduction happens. Now, manufacturing as a service. This is a model that is being used in China. You have heard about Alibaba, most of you have, and India Mart in India. What they do? You place certain amount of order. You want to manufacture this remote. What problem with this remote is it can fall off, and if it falls off regularly, it can break. Now once it is broken, what will happen? You need to buy one. So you can have a company which gives an order to some company in China, okay, which is manufacturing remotes for everybody. But since you have placed an order of minimum order of let's say 50,000, 5,000 remotes, you will get that reward, and you can sell them to the colleges that this is a spare one, keep it with yourself. If this breaks up, use the other one. Clear? So that means now manufacturing is a service. You want to launch your own paracetamol in the market. You go to Chandigarh, you go to Haridwar, place the required amount of order of paracetamol tablets with your own brand name. Let's say Amit paracetamol. They will manufacture it for you. They will use your own license. All the certification they will use for your own. And what it will, they will write marketed by Amit. And you have your paracetamol. What you have to do? You have to consult a doctor, offer some commission, and you sell your paracetamols. So that is what manufacturing as a service. You want to sell anything in the world, go to China, go to a manufacturing industry, give the specifications, they will produce for you. You don't have to take any headache. Okay, you are not, they don't have the technology, you go to Japan, Germany, US, Europe, ask them to give the technology, give it to the company, and the company will make products, you just sell the product. Okay, so this is known as manufacturing as a services. So factories offer the services. Okay, factories offer the services. So via cloud platforms, means you have an internet, okay, the website is there, you open their order form, place the order, and it will be shipped on your desired location at desired time. User access that cloud as a service. Okay, user accesses the manufacturing as a service. So nowadays, if you want to actually sell something, so you don't have to actually manufacture it. All you have to know is to understand the market gap. What is the gap that this product will sell or not, and accordingly you can sell. For example, you can make your own pencils. You give order to these small factories. They may manufacture pencils, crayons, glue stick for you. You can sell them to schools, stationery shop at reasonable prices. You don't have to actually put a factory to actually make those things. So this is the concept. So there are two pillars, factories and service and users. So how it is happening? Because we have added modules. Easily add multiple interchangeable modules or blocks. So suppose company is producing a pen, somebody is writing Rotomac on that. Another company comes, it says now manufacture the same with a different cap with different color. So they replace the module in their assembly line. Okay, now this module will produce hexagonal cap. Okay, so
they have to do very little change. Earlier, you have to go to the industries who are actually manufacturing the dies. Now you have to bring that die, test it, then you install that on that machine, and then you will have hexagonal, caps. Nowadays, things are changing. Nowadays we have 3D printers. You want to do something, you want to manufacture, you want to test something, you can print it as a first prototype on your 3D printers. Okay, give that program, the source code to the company will manufacture to you, for the same. And one of the finest example is Agnikul. How many of you know Agnikul? You know about Agnikul, India's first private rocket startup. Okay, just like SpaceX by Tesla. Okay, Mark Zuckerberg, that fellow is Elon Musk, yes. Okay, so that is what the thing is there. I was taking, I was delivering an lecture on machine learning in IIT Delhi, and on the first row, I don't know, there was some fellow who was sitting like, some Baba type fellow with lots of big beard, with beads, lots of beads, and he was wearing Hare Rama, Hare Krishna type of attire, and he was sitting calmly. And then after my lecture, he came to me that, sir, I'm very impressed with this, and we exchanged some words. And then I asked him, from where you are coming to attend this lecture? He said, I'm coming from IIT Madras. Madras, you came here for machine learning? He said, yes. Then he had given me one, IIT Madras Chitra Katha. They would give it to, just to intimate that how the IIT Madras was started. Then I asked, what do you do? So that he said, I'm India's first civil engineer who had started making 3D printers for making houses at a very low cost. So he's working, he wanted to incorporate machine learning into the house 3D printing. So 3D printing is the next era of thing. Okay, you can buy a t-shirt from Trichy. Okay, you can put your National PG College logo over here, give it to the students. Now, you do not have to worry. The 3D printing machine for making the t-shirt itself at your college can be installed. Okay, so that is the era that will be revolutionizing the things. And it is coming very fast. You will have this. So we have remote modules. Easily remove multiple interchangeable modules or blocks in your assembly line. Rearrange the modules, and you can have the next production, a different type of a product. So this is what achieving flexibility with interchangeable modules. Okay, now what is smart factories? Smart factory means interconnected machines and system. Okay, operate smart factories, functions as an advanced manufacturing functionalities through interconnected systems. And we have integrated advanced technologies, which utilizes IoT, AI, robotics, data analytics to power the facility. So we have interchangeable modules for making the things. Then we have interconnected machines. Then we have smart factories. So that means one small cluster is manufacturing something else. One smart cluster is manufacturing some other part, and third company is doing the assembly. So we have integrated advanced technologies through IoT, AI, robotics, and data analytics to power the facilities. Or you can have all the three clusters at one place under one roof, and you have smart factory. Now this is how it works. You see, this is a factory doing something. So we have sensors and IoT devices which are actually doing what? Collecting real-time machine data. So whatever slides you have just seen, okay, this is the culmination. Everything is being summarized into these slides. So we have cloud and edge computing. The data is flowing to cloud through data pipeline and processing. Okay, through cloud we have AI and analytics that is doing pattern and anomaly detection. You can do quality inspection. the quality inspection market is very, very big in India, especially in automobiles. Hundreds of parts is being manufactured. Okay, and then you take a sample, test what are the dimensions are, how many threads the screw should have, how many machines have made. Now, this was all done by humans. Now we have smart AI systems that is doing the same thing at a very fast speed. Okay, I'll come to that point. So we can detect the patterns and anomaly detection. Then your team can sit down together and take operational decisions. And if you give the feedback, it is a continuous learning, continuous, constant improvement. So you have precision, you have, self-improving things. Okay? And they are available at your fingertips. No need to do. No, you don't have to dream big to do some unimaginable things. Okay? These are all possible with just integration of small technologies. So in simple terms, a small factory is digitally integrated and intelligent production system. So whatever battery is out of order. So I think I'm audible?
Yes, sir.
No issues, no issues. Because I've been habit of taking long classes, so I speak in a large volume. Oftenly I get complaint from my family that you are shouting at us. I'm not shouting, I just wanted to make sure that the last bench also able to hear me out. Okay, so the pitch and the volume of a teacher as he progresses in his career, it elevates. Okay, so I frankly don't need a mic for that. So this is what digitally integrated and intelligent production system is there. Okay, so this is what the outline of the smart factory is there. Anyway, so moving forward, so you have understood the smart factories, and we also understood the small components through which we can have a smart factory. Am I clear? No doubts? Because I do not want to do the complicated, propose you complicated things that inside this AI system, this algorithm is being used. You have to draw an outline to understand what is Industry 4.0 is. And when you are actually helping a student for startups, or you are doing your own startups, then you need to understand and study each and every step in detail, so that whatever item you want to produce in your smart factory, okay, then you have to dive deep, or else at this level it is okay. You should develop understanding. Okay. So a smart factory means increased efficiency. Okay, you are increased efficiency. You do not have to employ several employees. One is looking after this part, one is looking after this machine, one is looking after the temperature, pressure. Everything is automated. It is available on your desktop, and on the single screen, warning will come that this is about to go out of order. You take the decision what to do. Then we have real-time monitoring and predictive maintenance. Predictive maintenance means sensors detect problem before failures. That is a motto. And reduces downtime and maintenance cost. Because if machine goes out of order, you do not put your vehicle you do not give your vehicle for service at a proper time. Once you visit a mechanic or a garage and say, साहब इसका ये भी खराब हो गया, ये भी खराब हो गया, ये भी खराब, प्रॉब्लम सिर्फ एक जगह है, लेकिन खराबी 3 जगह बताई जाएगी. Clear? But if you precisely know where the problem is there, आप जाओ गैराज में बोलो इसका जो दूसरा वाला जो वो है ना वायर वो वायर हटाओ and everything will be okay. So this is what happens. So improved product quality. So you have better product quality, flexible and customization. Okay, easily adapt to new product or changes, support mass customization. Earlier the concept was that suppose you are manufacturing something at some standard part. Now market is demanding for a smaller part or a big part. You have to change your production machines. Now this is not possible. This is possible with, in fact, zero cost. So you can adopt to new demands and product customization. Cost reduction and sustainability. So this is how your business can survive, because optimized resource uses is there, less waste and energy consumption. Less waste is produced and you consume less energy also. So characteristics of smart factory: self-optimization. And how it happens? Data collection through sensors, then data analysis, AI, then automatic adjustment for self-optimization, okay, speed, quality, for whatever the motive of optimization is there. Then you have a continuous improvement. So this is a vicious circle in which you have self-optimization. So this is fundamental characteristic of a smart factory. Now self-configuration. That means what can happen? You can have a different task, product or conditions. So these change. They change over a period of a time. For 6 months, certain conditions, certain product is in demand. After 6 months, the product altogether drops down from the market and you have a new demand of a product. New demand of the product. So what you have to do? If you have a smart factory, then automatically it will adopt and configure. So you do not have to change the entire machine. You will be sustaining in the business. The earlier model was you can make only one precise component or a product, and that is all. If that product is out of demand, you will shut down. You will be incurring losses. Now if you have a smart factory concept, so your losses will be reduced. You have a better chance of surviving in the market. Now smart manufacturing architecture moves around 4 things: sensor, data, analytics and actions. 4 things. Clear? Sensor, data, analytics and actions. So data, sensors collect the data, you do analysis over there, and then you take smart decisions, informed decisions. Decisions are not taken intuitively, they have a scientific base. Because you see all the facts and figure, and then you adopt, okay, this is going wrong, so I should change this. Now role of IoT, this is how a real monitoring software is there. I have also made this one predictive maintenance system. Actually it is under development in association with Boolean Microsystems Private Limited. So this dashboard is not belonging to that system, because I have signed an NDA with them, but this is how it is taking. Okay, we have a sensor data, temperature is being maintained, okay, it is displayed, pressure is there, humidity is there, other parameters are there, vibrations are there. Means vibration sensor is measuring and collecting the vibrations, and alert is there because of high vibration detected. Okay, so we have production defects and all kinds of analytics are there. For every part, every machine which is being in your in your smart factory, you have AI dashboards like this. Okay, you come to know without visiting the factory. You are sitting in the office with your single chair, assembly line production is going on, and you come to know where the problem is, what should be done, what should be replaced. And this also, if that employee switches or retires, new employee can automatically adopt at the same efficiency, okay, at same level. He is also same informed as the previous one, because everything is automatic, it is visible. Now decision making, so it has a data input from various sources, okay, then AI processing is being done, there are feedback loops, okay, and then action is executed, and this is what the decision making happens. This is how through the decision. So the first thing is what you need is you have a data. Data is there, you have AI systems that process the data, and there is a feedback loop which continuously improves the decision taking, and then you have action and execution. So this is how it is happening. Clear? Any doubts? So role of robotics. Now first part is over. Industry 4.0. I've given you brief introduction, how it happens, what are inside things are there. Now we'll talk about robotics. So first thing is that we have Internet of Things, then we have processes, okay, then we have production line, then we have a robotic arm, okay, and then we have machine learning. So these 5 components are actually part of automation right now in Industry 4.0. Clear? Earlier we did not have this machine learning part. We had robotic arm. Okay, that is Industry 4.0. If you remove this Industry 3.0, that means we have a production line. Clear? So this is how the parts of automation. Clear? Very simple with infographics. Easy to comprehend. Now, there are various types of industrial robots, and you should know what and how, which kind of robot are being used and where it can be, where it is used. So industrial robots refer to use of programmable machine in manufacturing and industrial environment to perform tasks like assembly, welding, painting, material handling and packaging. And remember, these are repetitive tasks, okay, where humans commit lot of mistakes. Lot of accidents happen on the assembly line. People have got limbs, fingers chopped off because of safety, because it was a repetitive task. You started talking to your colleague, you're working on a machine, and your hand was accidentally inserted into a moving part. An accident is there. So we have robots where we have a repeated task at a high speed, accuracy, precision is required, and task is assembling, welding, painting, material handling or packaging. So you can employ a robot. Okay? So these robots are automatically controlled, highly precise and fast, capable of working continuously, used to improve productivity, safety and quality. So you use robot, so you get 4 benefits. Now first type of industrial robot is articulated robot. That means multiple joint robotic arms like human arm. It has various degree of motions. Okay, the first is T axis, B axis, U axis, R axis, L axis. So that is basically the degree of motion. So very flexible, and where it is being commonly used, welding, painting and assembly. So these have, and normally in engineering college like Ambalika and others, they demonstrate this kind of robotic arm. Okay, that can pick something. If you change the tool over here, okay, instead of polishing it can do drilling. Okay, and you just change the tool, it will move to the precise location, do a hole or make a drill for you, paint the surface for you and come back. And the speed, you can control the speed also. Then we have Cartesian robot. As the name suggests, they are capable of moving X, Y, Z axis. Okay, they have high precision. Simple design uses are means they are used in CNCs and 3D printing. You have seen a 3D printer, something like this. Okay, this robotic arm is actually stamping these boxes. Okay, so these are known as Cartesian robots. Then we have SCARA robots, best for horizontal movements, accurate, used in assembly lines for electronics. You have a PCB board, you have to install the components, you have to do weldings, soldering of that components. What you use? SCARA robots. Okay? So this is the third type of robots. Then we have a Delta robot. Now what the Delta will do? It is lightweight, very fast, used in packaging and sorting. Ideal for small and lightweight parts, items. So suppose that you have to sort an item. Now this delta robot will actually pick an item which is not in good quality. So it will remove from that line. It will drop down to the floor or will collect that item to some bin for discarding. So this is the work of delta robot. Now we have a collaborative robot, last one. So the collaborative robot, they actually help humans, okay, where safety is major concern. So we have collaborative robots. They are easy to program and flexible because as per your need, you can program them. They will help that human being. Suppose what happens? Suppose that you have to take part out of that machine at a very desired speed, at a very precise speed. One simple fatigue can actually chop off your fingers or limb. So this delta collaborative robot, you have a robot, you program it, at precise moment it will go inside the machine, pick the part, okay, and come back. So this is what a collaborative robot is there, working alongside with the humans, easy, flexible for in programming, and used in small scale and flexible productions. Now advantages of robotics: efficiency, accuracy. Challenges: cost and skill. To install a robot, you invest a lot of money. And skill means that you have to keep a programmer which can do, because these robots have special type of programming language. You have to learn that programming language, write a program in that language and test the program. Okay, so that skill programmer should be available to you. Okay, the human robot interaction, that is HRI. The focus is work together safely and efficiently. The safety is major concern. So prevents accidents, enables a safe shared workspace. So that means ensuring safe collaboration between human and robots. Use of sensors, camera, vision system to detect human presence. Emergency stop mechanisms are there. Speed and force limitation. The ISO standards are 10,002, 180, and ISO RTS is 15066. So this is the standard that of safety robots. Physical safety tools like light curtains, safety mats, and protective barriers that you have to use. So this factor you have to keep in your mind in your smart city, smart factories if you are using robotics. Okay, now usability. Improve productivity by making robots accessible to non-experts. So suppose you have an expert employee retired, you want to replace that employee. So if you have this HRI factor with you, so you can replace that employee easily. Okay, because this robot will help assist that employee. Employee will learn, the worker will learn easily how to work on your assembly line. So designing robots that are easy and intuitive for humans to use. User-friendly interfaces should be there, touch screens, teach pendants, voice controls. Simplified programming and operations. And one of the most important thing is ergonomics. I think present student don't know about ergonomics, but earlier means student of my batch of engineering, they know ergonomics. There is a simple ergonomics means there is a definite temperature that should be maintained inside a factory or a workplace, so your body feels comfortable. You are not stressed. You are not over sweating like in these humid conditions. AC and proper control is there. If the temperature is too high, you will sweat. Your energy will drain off. If your temperature is too low, you will feel cold, shiver, and you will not be able to work properly. Your table height is designed at a level where you are taking average height of your general population. Okay, so that you do not have to work you are putting your hand on top of the table or it is too low. So this is ergonomics. And at one level, another level of ergonomics is that suppose you have to move this item from this place to some another unit in the production line. So the physical movement, okay, to move this item should be as minimum as possible. So you have better efficiency, less accidents and less fatigue. So these all was study of ergonomics. Anyway, quick setup and adaptability for different tasks. Okay, you know, restaurant tables are very ergonomically designed. They are neither too high, neither too low, so that you can properly dine. Okay, clear? So, ergonomic designs for comfortable human interaction, quick setup and adaptability for different tasks, reduced training requirement for operators. So this is what usability counts. Okay, so automation levels are there. First is the manual. All tasks are performed by human. Okay, so this is level 0. Example, hand assembly, traditional workshop. Level 1, assisted automation. Basic tools and machine support to humans. Like instead of manually drilling the hole, you have a proper tool. Okay, drill machine is there that can drill. Example, power tools, basic machinery. That is level 1 automation. The 7.2 is semi-automation. So we have machine handles the repetitive task, humans supervise and control the operation of that machine. Example, CNC. Okay, so CNC machine is level 2 automation. Okay, or conveyor system. Automated level 3, system operate with minimal human intervention. Example, automated assembly line. So it is all pre-programmed. One part moves to only one specific direction or at one specific distance. Other robot handles the next part. Other robot handles the next part. Okay, 4 robots collaboratively are welding on the same assembly line on a chassis of a car. So your car chassis is being welded in one single shot. Okay, for paint shop, the car goes to a paint bucket. Robot picks up the entire car, dips into the bucket, pulls it out. Okay, sends to the drying area. As soon as the car reaches the drying area, specific temperature is maintained, and your car entire paints dries off at a same speed. So that is why when you have a car, there are no dripping marks. There are no dripping marks because every surface of the paint has dried at a constant rate at constant speed. Right? This is because we have industrial ovens. Okay. Now fully automated and autonomous level 4, that is self-operating systems with AI-driven decisions. Real-time optimization and adaptability is there. Example, smart factories and autonomous production line. So we are at automation level 4. Okay, for smart factories. So these are the 4 levels. Now whenever you see some worker in a garage working with power tools, you will come to know that it is at level 1. Okay. Now this is, if you have understood everything, now we can pull back. Now predictive maintenance. So we have a machine is working. Machine is actually through sensors, it is logging the data and sending to an AI model. It is feeding the data to the model. The model is what is doing? It is sending alert notations to the mechanic, okay, to the technicians. Technicians come, repair that machine. So your production is continuous. Now this model is also what is doing? It is sending data for storage, and you can take you can find the anomalies and model, and this model is self-improving because it is periodically trained by this collected data. Okay, by this collected data you can train, and then you have a dashboard. Clear? Now the importance of this is that because this unit machine and its model, let's say, are working, there is another machine which has been operational for 40 hours. Okay, that machine's parameters will change. It will send different kind of data, and you can, let's say, machine shut down after 60 hours. So machine 6 shuts down after 60 hours. This has been operational since for 10 hours. So this model will send the alert that maintenance is required because 50 hours has been passed on. So this is what a predictive maintenance is. Now, AI-based inspection. This is very important because we have high-speed industrial cameras. They are intelligent cameras. They take the photos. The AI will analyze the parts under production, find the anomalies, detect the quality, checks the quality, okay, checks all the parameters. Then it will if find some anomaly, some problem, okay, then it will classify that problem. Then it will send to by using real-time processing, it will send that information within milliseconds. Then decision making and action can be taken whether to discard that product or not. Then you can send the alerts that why this is happening, which part, which motion, which system in the assembly line is malfunctioning, and then you can perform your improvement. So this is the continuous, all connected, seamless things, quality control. Okay? So this is how it is happening. You know, there is a small case, very good case studies being taught in Japan. A fellow went to a supermarket to buy a soap, and he purchased 3 soaps. When he came home, he found that one soap box is there. Inside there is no soap. So that fellow was actually given a thought for 2 or 3 minutes. Then he said, I should write to the company that this fraud happened to me. So he's written a letter to the company that I purchased 3 soaps, and in 3 soaps, 2 were there, 1 soap was missing. Clear? And the company was, Japanese are very serious. Say they have written an apology letter, shipped 1 piece of soap to that fellow, and that fellow was happy. And inside the Japanese company, all the engineers sat down, why this problem happened. Who forget to put soap in the box, packet. So they have given this problem to certain set of engineers, and they designed the system at millions of dollars of cost. And when the system was being inaugurated, the general manager of the company came, announced that we had this problem, that one fellow purchased our soap, and inside that soap, out of 2 were there, 1 was not there. So we thought that this problem shouldn't happen. We are very strict on quality control and reputation of our company. So we have installed this system, and this system will actually take care that no box passes down without any soap. So there was a senior, very experienced old employee who started laughing. So everybody was turning back. He said, what's the wrong with this fellow? Why are you laughing? Because we are about to inaugurate such kind of a system. He said, you wasted millions of dollars on this line, this problem. He said, what? So then how you would take care of this thing that would never happen? He said, I'll just put a high-speed fan. If the box is passing without the soap, it will blow off. Everybody was puzzled. We never thought of this kind of solution. Clear? So there are very clever, intelligent things available in your environment if you have a broad perspective. Okay? So, but nowadays we have high-speed industrial cameras equipped with AI. Clear? I've seen picture on a net. A person is buying pack of tablet strip, and they're supposed to be 10 tablets. I don't know what went wrong. There are 9 tablets, 1 is empty, and it's perfectly sealed off. And he has posted this online. Now, what happens? These medicine companies, they used to have an inspection fellow, but since the medicine's production is at a very high rate, due to fatigue, due to chance, 1 strip must have been passed off quality control. People never inspected. But you have AI cameras. They detect everything, whether the tablet is present in the strip or not. If you are producing a screw of, let's say, 2 centimeters in length, they will calculate the length of that screw from the image itself. How many threads should be present on that screw? The AI camera will analyze. Okay? The AI cameras will analyze and they will count the number of threads also. Whether the stamping is there or not, everything they will count. And one of the, if you explore this net, you will have Texas instrument software is there. Okay? And you can download, you can work with it, and you can install. But the condition is that you have to purchase Texas Instruments AI camera, and you can train it on any model and install on the assembly line. It will count that production is as per the quality standards. So this is what? So AI cameras detecting defects in electronics, automotive parts or in packaging line. Okay, so this AI camera is detecting the surface defects, this is detecting the dimension defects, some other is detecting some other defects. You have to install 4 to 5 cameras, but these cameras are costly. And you have a panel, okay, which is showing you the number of defects, when it happened, how it happened, and you can take the countermeasures so they are not repeated. Benefits: improves the quality, product quality and consistency, reduces the inspection and time and cost, minimum wastage and rework, and enables continuous monitoring. In Lucknow University, there is a course on quality. Okay, and that course they take only 30 students at a time, and all of the students get placed because that is because of quality control or quality inspector is required in every industry, and it is not a very technical field. It is, you don't have to do any specialization to actually, but all you have to you need to have a degree in quality. So that is also one of the, after doing graduation you can enroll yourself in quality, and it means software companies also come and pick up those students. The production companies, they also come and pick up those students, and you go and work in the plants. Okay, and all you have to do is just to set up the or adopt the quality standard of that company. So minimum wastage and rework enables the continuous monitoring. Now case study 1, Tesla's Gigafactory. So I have made 2 slides out of Gigafactory, Tesla's Gigafactory. If you are interested, this pointer will help you. You can explore much more detail is available on the internet. So Tesla was the first one. No, not the first one, but it is the one of the most highly talked about gigafactories. Okay, so use highly automated production system. The key technologies are advanced robotics, IoT sensors, AI analytics, and digital integration. So these 4 are the key technologies used in Tesla's Gigafactory. This is what you see. There is hardly any human in this Gigafactory. In fact, no, except the security guards and those kind of fellows who are just shipping the material. And thus Tesla's is producing the cars, okay, with minimum number of workforce, and the quality is top notch. So this is one of the pictures, Tesla's Gigafactory. And another one is Siemens. This factory was actually inspected by Angela Merkel also, then the Chancellor of West Germany. So Siemens AG Electronic Works Hamburg is one of the world's most advanced Industry 4.0 smart factory. It produces programmable logic controller PLCs used in industrial automation. China is the production house of the production floor of the world, but Germany is the country that supplies all the machineries to China. If Germany stops machinery support, China will shut down. Okay, and in industrial production, PLCs are required. Okay, so they are required for assembly lines. So highly automated production, over 75% of the process is automated. Machines communicate with each other in real time. Industrial IoT integration, first time we saw. Sensor track every stage of production. Data is continuously collected and analyzed. It uses digital twin technology, and this is how we came to know about this word digital twin technology. So virtual models simulate and optimize production. Okay, before entering into production, you simulate everything on the software. You know, Indian Air Force flies Rafale. Everybody knows we have Rafale. No, before actually we have this Rafale. Rafale also manufactures a software with the same name. And the beauty of that software is that actually it is very costly. You can design everything on that software. Parts by part, component by component, put them everything. You can design an engine and make that engine move. Start that engine in the software itself. You can simulate the operation. That engine is being operational since 40 hours, 60 hours, 70 hours. Which part will go out of order first? Which bearing will be weared and teared out? Okay? Which screw will be under stress? Every analysis of the part is there. And that is why that they developed the software first. Okay? Then they have produced this aircraft, and that is why Rafale is on the world's top list. Okay, so I have worked on the software in 2008 when I was working in Integral, but only free version is not available. It is available for, let's say, 1 week, 1.5 weeks. So within 1.5 weeks, there was not YouTube was also not popular at that time. So I could only make a small system, and I just executed the system on that Rafale. So every company has its own software, proprietary software. Okay, on the software they simulate everything, and then they go to the real world, and that is why their startups, their companies are more successful. We have a habit, एक फैक्ट्री लगाते हैं, वहाँ पे पहले ये मशीन लगाएंगे, ये बनाएंगे, और फिर end of the day product fails. So when I went for my engineering, so at that time ragging was actually at topmost level. इतना ragging होता था कि आप सोच ही नहीं सकते. So we used to run away from the hostels. So what you'll do if you run away from the hostel at night? So you need some place. So we purchased rented a small room in the main city. So as soon as the college was to get over, so we used to run away to that room, and that room was belonged to our landlord, and landlord had a small factory. Okay, so I used to observe what is going on in the daytime, on Sundays particularly. So I came to, I was interested, so I started talking with the landlord, and came to know, अंकल जी कुछ और बना सकते हैं, कुछ और बनाइए. So यार बड़ा प्रॉब्लम है यहाँ पे. मैंने कहा क्या? कह रहा एक मेरा दोस्त था, उसको समझ में आया कि यार मैं हैंड पाइप और ये प्लम्बरिंग सिस्टम्स का वो सामान बनाता हूँ, पाइप्स एंड वगैरह. तो उसने सोचा वो नहीं टैप बनाता है. तो वी हैव फॉर मैन्युफैक्चरिंग टैप्स, प्लास्टिक टैप्स, you need a die that will, you buy the plastic beads, and then there's a die, and you heat that beads to a particular temperature that will press and make a tap for you. Okay, so tap has the only product which has 2, 3, 4 moving parts. Okay, easily you can manufacture and sell it. Okay, so my friend had a factory, used to manufacture that. He purchased die from the Merit. Purchasing die means a casting piece. If you go to industry in Pune and other, they will charge you exuberant charges. But in Meerut, we have a government institute that supports the startup and Indian industries, and they make dies at a very cheaper rate. It's a government office making dies for the public. So he went there, and he requested them to make a die for a tap. They made a die, and he brought that die and started producing taps. And he produced taps around 3 trucks. And there is a wholesale market near to the Delhi where he went to sell that taps. And he sold the tap within a month. He sold the tap. And after 1 month, the taps came back to the same market. And the problem was identified. Everything was okay. But once you install the tap, open that, okay? Open the tap, no water used to flow. Because the die maker forgot to insert a hole so that water can come out. Everything was there. And you know, that uncle ji told me that मेरा दोस्त परेशान हो गया, अब मैं क्या करूं? तो उसको जो अदर लोग थे उन्होंने कहा वापस जाओ डाई वाले के पास, उसको भाई डाई तो बन गई, टैप तो बन गया, लेकिन उसमें तो ये तो बनाओ इनलेट बॉल, पानी बाहर तो आ सके कम से कम, वो होल ही नहीं बना, टैप बन गई। तो अब यू कैन इमेजिन आदमी ने प्रोडक्शन शुरू कर दिया, बंदे ने सब कुछ 3 ट्रक माल बना लिया, बेचने गया वापस आ गया, because there was no simulation, no software was there to support these kind of things. So what Indians believe पैसा लगाओ खूब सारा और जाके फैक्ट्री डाल लो, आराम से बैठ के सो, सब कुछ होता है. It is not there. People in West, they make the softwares. Whatever software is missing, that component they do it by themselves. Clear? And then they make that. Okay? You know, what's best institute for engineering? Anybody know? No, it's not what's best.
MIT.
MIT. So I had this design idea, but not exactly the design idea, but I was thinking on some prototype. So I was exploring the net. I came about across the electrical department at MIT. So we had, I was actually exploring the problems of wind energy. So the problems of wind energy is that you can install the wind turbine. In India, Suzlon does that. They make turbines. But there should be a continuous flow of winds. If the continuous flow of wind is not there, you install a turbine, you will be bankrupt. Because you will not be able to repay the loan to the bank, or you cannot reclaim your capital back. But at certain height, you go to high-rise apartments, on the 12th floor, you always feel the wind. Decent enough wind is there. That is why people in Mumbai, the 5th floor apartment cost is less. Okay? 10th floor apartment cost is high. 20th floor apartment cost is very, very high. And you heard the word penthouse? The penthouse is on the topmost. The reason for that, at lower level, at lower height, the pollution is more. At upper layer, if you increase the height, the pollution effect is less. Wind is continuously there. Clear? So what that fellow designed at MIT, he installed it was actually a turbine, wind turbine. It was filled with surrounded by a material, also balloon type of a material. He filled hydrogen in it, helium in it. Helium was light, and that turbine was connected with a cable, and he started increasing the as he started filling the helium, the volume increased. और जैसे बैलून जाता ना, आपने देखा बैलून, वैसे ही उसका वो टरबाइन ऊपर उठने लगा. And that turbine was tied to a cable at a desired height. You know, a turbine tied है cable में, and wind was there. It was working 24/7. And I thought that this is a very brilliant idea. Nobody in the world could have this. He had this. So I was working. So I had chance to actually interact with them. So he said, I made a software first to simulate everything, that whether my idea will work or not. When he was successful in simulation, then he went for funding. Now he's installing those kind of system at a very remote locations, where there is no connection to the power grid. Okay? Suppose that there are 10 houses in desert or some hilly areas. It is very difficult to actually connect to that town or small 4 to 5 houses to the power grid. So at that base, his solution works. Okay. For that, they do it on the software first. Let it be any branch, mechanical, electrical, anyway. They do it on the software first, then they actually physically realize that product, or they go to production. In India, the things are, we are conceptually told machine banao pehle, फिर देखो उसको चलता है कि नहीं, तब तक आप बैंकरप्ट हो गए, घर वालों ने लात मार दी आपको, आपका सपना वही टूट गया. तो दैट इज व्हाई वी आर ओनली हाफ बेक्ड इंजीनियर्स. We are being we have knowledge of everything, we have imagination, but we don't have the proper softwares for that. Clear? And with only one reason in mind, one question, कि सॉफ्टवेयर तो केवल कंप्यूटर साइंस वाला ही बनाएगा. ओवर देयर एवरीबडी मेक्स देयर ओन सॉफ्टवेयर. वो किसी इंडस्ट्री में वो अपना सॉफ्टवेयर खुद बना रहा है, एंड दे डू इट ऑन दैट सॉफ्टवेयर. They realize concept is working, then they start it. Clear? So digital twin technology helps you if you make your software first. You know SpaceX, that vertical launch system? Can you imagine? This rocket, that system was made first or the software was made first? Software. Through software they controlled every parameter. They remade the system. System was malfunctioning. Imagine what would have happened if it was being done by the some Indian company. Entire setup used to fail. But their engineers sat on the software. They found out where the problem is. They found the problem on the software. They corrected, replaced the part in that physical system. It successfully flew up and came back. Clear? You know this F-35. F-35. Does somebody knows F-35? What is it?
It's a fighter aircraft maker.
Yeah, it is a fighter made by Lockheed Martin. Two companies were in competition for supplying fighter planes for 20 years, Boeing and Rafael. And Boeing's prototype had a problem because the engine used to actually send the unconsumed fuel, and it used to come out like a flame. Okay? And on the test bed, it showed this problem. Their Boeing engineers sat on the software, found the problem where the problem is, and they corrected it, and it was working fine. And in India, we have a prototype. Now we'll redesign that prototype, come back after 20 years correcting this problem, then we'll find another problem, and that is how we mature the technology. So their software is must, because on software they simulate everything and then they produce. Okay, so real-time quality control is there because AI supports you. Production capacity increases significantly. Defects reduced to near zero. Faster production with high flexibility and continuous self-optimization using data. So this is case study 2, Siemens. This is the plant making PLCs for entire world, and you can count how many humans are there. Okay, very less. Okay, so if 100 persons are required, they use only 25% of the human beings. So this is Siemens factory. Case study 3, Tata Motors. We are not behind. Okay, so Tata Motors manufacturing plant in Pune and Sanand are the excellent example of Industry 4.0. Okay, these facilities integrate automation, robotics, IoT and data analytics to create efficient and flexible production system. You see that Tata has been launching models which are very good looking. They catch the market and they are in competition again. Imagine the era of Indica, Tata Indica. Tata was out of. And Lucknow public knows what happened with Tata Sumo. Nobody buy Tata Sumo because as soon as you purchase Tata Sumo for your own self, you are on the road, people used to go, भाई मुझे पे बैठा ले. उनको लगता है किराए की गाड़ी लेके जा रहे. So nobody actually purchased the Tata Sumo. What went wrong with Tata Safari? You buy with आपकी जो इमेज ना वो बदतमीज टाइप के लोगों में आ जाएगी. सफारी से चलता है. Right? Now you have Tata Curvette, Tigor. Now these are very good cars with no vibrations because they have got an excellent production line. Everything is controlled with the software, and they can launch models means within 6 months they launch a new model. And in competition, Maruti, they have nothing to bother about production and something. As soon as something is going out of date in Japan, they'll buy it. Don't throw that assembly line to sea. Please give it to us. That is a case study of Tata Swift, Maruti Swift. Swift was actually discarded technology, discarded car in Japan. So this Maruti Suzuki collaboration was there. So Maruti people went to Japan, please don't throw it, give it to us at half the cost. We said okay, welcome. And they came back to India, and in Indians, Maruti's new Tata, this Swift is there. Very popular car. Everybody started buying Tata Maruti Swift. Very good car, but it was a discarded technology. You take the cost of this Hyundai, Korean company, good cars. Accent and other kind of variant are there. But there are less models in Hyundai. You see Accent, you see old Accent, you come back after 10 years, you again see the Accent itself. There is no new model. And the problem with Hyundais are, they are actually, they don't run on your petrol, they run on your blood. They consume so much fuel that it's very costly to operate. And we Indians love good cars at a very, that is why Maruti is very popular. Now Tata is in between, inserting itself. And this is all because Tata have adopted, they changed their technology. They started working on software. And this is only possible because they acquired Jaguar in UK. So their software, proprietary software, they are shipped back to Tata's. Now Tata has every technologies and it's okay. And the vision of Tata's is something different. You know who controls internet in India? Who controls internet in India? It's Mota Bhai, Ambani. Okay? Now Ambani's father laid an underground sea cable at its own cost, and that cable comes to Mumbai, and something goes wrong in Mumbai. Every India's internet connectivity is shut down. Even Bharti Airtel is dependent upon that cable. That is what Dhirubhai Ambani, who was not even educated. That is his vision. Now that is why they have to do marriage of their son. They increase the price of Jio subscription. What you can do? Nothing. They've increased, Airtel also increased. So they are also not out of competition, and Airtel has to actually increase the cost because they have to stay in competition. Because Ambani's will charge backdoors. Now the data rate has been changed for you. Clear? So if Ambani's want, they can shut down Bharti Airtel within minutes, because they have control over internet cable. And you know what Tata did? Tata's laid the same cable for 128 countries in the world. If Modi makes a telephone call, our government makes telephone call to Tata, so please shut down the internet cable, Europe will be without data. Tata has done it for 128 countries, but they do not publicize it. They operate silently. And that is why Tata's do silent acquisition in industry. Clear? Jaguar purchase was being, every expert told that no, this is very costly, and what will you land up? You will land up in bankruptcy. Tata's did it. There is a Professor Jay Prakash, Professor Prakash Singh at IIM Lucknow. Okay, so we had this 1 week program. I was also a part of it. So he was a part of that acquisition. So 300 CAs were flown back to UK. They were continuously a part of the deal. And Ratan Tata, he didn't sleep for continuous 3 days for that deal, to close that deal. He was one of the part of that team. If you have a chance to meet him, he will share the inside story of what happened, how after 2 hours it was being assumed that deal will happen, and after 3rd hour, 4th hour pass, no, we will not be having any deal. So again, but it was the actually genius of Ratan Tata that everything was acquired. So we have 2 or 3 persons from IIM Lucknow who were the part of that team. So they use industrial robotics, okay, industrial IoT, data analytics, and digital monitoring systems. So what happened? Increased production, reduce the downtime and defects, product quality, flexibility in manufacturing, and better decision making using real-time data. So this is the picture of Pune's and Sanand plant. You see the car has been manufactured by fully robots, no defects at all. Now Industry 4.0, the current status, adaptation across industries like Tata Motors, Mahindra and Mahindra is doing wonderful job. They have they penetrated such kind of markets which are being were earlier assumed as you cannot do anything about it. First, the toughest market is Australia. And the second one is USA. And Mahindra's penetrated them. Mahindra's penetrated Africa. Okay, in 4-wheelers. And they are very reliable. Except Mahindra's Scorpio. That has some problems. And one of my relatives faced a problem with my Scorpio. The Scorpio uses drive-by-wire technology. You press the brake pedal, sensors will send data to the main engine that please apply brake, and car will stop. So my nephew he works in PW department, and he was going for a road inspection. And since it was raining, so he stopped at a dhaba to have some chai and pakoras. And after that, he started driving. It was a big car, no need to worry about skidding and skidding. Okay, people see Scorpio, they take care of their own safety measures. Okay, because nothing will happen to Scorpio. You have. And I had one chance that fellow in sedan was actually sweating, and I was driving the car because I was he was on my left hand side, and I stopped, he stopped, and I started giving the indicators to take a left turn. So one of my friend told me, कुछ मत करो, वो बगल में है, वो दिखता नहीं उसमें से, और वो सोच रहा था कि कहाँ, there's no escape route. So he pressed some brake, nothing happened. आधा लगाया, कुछ नहीं हुआ, पूरा लगा दिया, कुछ नहीं हुआ. Then he called back to the showroom. अरे ये तो कार नहीं रुक रही है तुम्हारी, और ये there is a brake failure in. सर कोई प्रॉब्लम नहीं, आप कार लेके इधर आ जाओ. इसे कार लेके इधर आ जाओ. 110 kilometers Lucknow is away from me. I came for a road inspection. I'm going back to my office, and you said that. So it's nothing. Sir, वो sensor पे moisture आ गया होगा. Then he somehow drove to Lucknow, and what they did was normal hair dryer लेके नीचे से गए, dryer पे मारा, sensor में moisture लड़ा, मारिए ब्रेक लग गया. अब आप सोच सकते हो, आपका बरसात हो रहा हो, आप सामने खड़े हो, उधर से स्कॉर्पियो आ रही हो. So, yeah, these kinds of problems are there. Clear? And that is one of the main reported cases कि ऐसा प्रॉब्लम हुआ. And they know, गैराज वाले जानते हैं कि होता बस नीचे ड्रायर लगाना होता है. But आपको नहीं पता चलेगा ना, you are driving in rain. Okay? कम moisture आया, nothing will happen. Anyway, I'm not here to criticize somebody, but technology is there, so some problems are also there. Anyway, so electronics manufacturing, pharmaceuticals and FMCG, steel and heavy industry. Large enterprises are leading. MSMEs are gradually adopting Industry 4.0 because it works on cluster, modular level. So many MSC can collaborate and make a big system. Growth, government initiatives, first is Make in India, Digital India, Samarth Udyog Bharat 4.0, Smart Manufacturing Program, Center of Excellence for Industry 4.0. I'll give you a PDF I'll share to Dr. Shalini. She will send you that what are the UP government's initiatives in this field, what are central government's initiative. You can read the scheme, you can understand how much our government is supporting. There's 4.0. Strength, large scale workforces, okay? Growing startup ecosystem, increasing foreign investment, strong IT and software capabilities. Challenges, high initial investment cost because you need robotics, you need AI, you need softwares. Okay, high initial investment cost. Limited awareness in MSME. that you can do wonderful jobs. Okay, if you have one CNC machine, okay, you go to the market, you will be never out of job. You will always have some job to make, to produce something on MSME at a small level, because you have a CNC machine, you have a small lathe machine, and if you have your own CNC machine, you will never be out of work. There are so much orders, but people, they are not trained. They do not want to take a small, calculated, calibrated risk, and that is why you find a lot of mechanical engineers, okay, with no jobs. But if they are into production with small CNCs, one CNC or even a lathe machine, they never sit idle. There is always work coming, some job is to be done. So with that help, you can do. You can have your own MSME registered, and you can have skill gaps in advanced technologies. So these MSME, they can't afford, let's say, or they do not have properly equipped AI engineers, data engineers that can actually do analytics for them. Infrastructure limitation in some regions. Okay. Now opportunities. India's industrial 4.0 landscape offers massive opportunities for us. Pick any domain. Do not work for the company. Go to the industries directly. Say that I can make this software. Please test it, and that's all. Done. Okay. If you have a predictive maintenance software, AI-based software, the market is around 600 crores in NCR itself. Forget about Pune, which is automotive hub. Okay, so it's a huge market. Adaptation of automation across automotive, electronics, and pharma. You go to Mandi, you go to Haridwar, you go to Chandigarh. Pharmaceutical companies are there for, they need this kind of vision, inspection, quality controls. AI and robotics growth. Demand for intelligent automation and cobots. IoT and connected systems, smart factories, predictive maintenance, digital twins. If you have a machine, you can make a digital twin, you can sell that software to company. But you should know the company using which kind of machine, which kind of model. You have to do, just make a digital twin. Nothing, no fancy softwares, no app. You just make a digital twin of a machine and you will sell. Your manufacturer of the machine will actually buy softwares from you. He will sell to a customer. He'll say, please buy this digital twin also, because through this twin you can do this. And imagine the number of machines in India. Small power tools are there. You make a digital twin of a power tool by just analyzing the acoustics. Clear? And yes, you just switch on that power tool, drilling machine. The vibration it is making, the mechanic will come to know which part has to be replaced, and everything will be in fine order. Okay? You can make softwares for your cars. If some problem is there, they can analyze. Global supply chain role. India as a manufacturing hub for global market. Because after Corona, the world has seen that we should have a second option also. And in second option, the India is one of the favorite destinations for manufacturing hub. So there are lots of opportunities. Do not ever think of TCS, Infosys, and Wipro that they will come and they will absorb you for students. And you should also guide your students that please do this kind of work. Okay? If you do that, you will have plenty of opportunities. Okay? And if you sit idle that your college will call Infosys, TCS, and Wipro, it will never going to happen. Okay? So, job creation, new skill, roles in AI, data science, robotics, and system integration. Now, startups driving industry 4.0. In India, we have grey orange. It does warehouse automation and robotics. Systematics, industrial robotic arm. They make industrial robotic arms. And Altizon system, industrial IoT and data platform. And Detect Technologies is AI-based inspection and monitoring company. So if you do something in inspection and monitoring, you can approach these kinds of startups. So role of academia and skill in industry 4.2 is at two factors. One is skill, another is research. So skill development, the technical skill training. Train your students on AI, machine learning, robotics, IoT and data analytics. Give them hands-on learning, provide labs, workshops, internships and real-world projects. Curriculum modernization. If you have the limitation, if you have the power to modify the curriculum, then please change it so that and incorporate this kind of a thing, so your students will become more employable. Or provide some add-on courses, okay? Some add-on courses so that employability chances are improved. Industry collaboration, you can partner with the companies for training and certification. You can send their students for internship, okay? And employability focus, prepare students for industry 4.0 jobs role. You've seen electronics dying in India. If you analyze the picture of engineering college, every engineering college have either no physical existence of electronic branch. Why? Because everything is modular. You go to Charbagh, okay, that market, electronics market is known as what? Naka Hindola, yeah. You go there, you want to connect something to Wi-Fi, 50 to 100 rupees module is there. Buy it, give it a power supply, you can start sending signals on Wi-Fi. Okay, you want to do anything, modules are available. Why? Because people in Bangalore who are working for Siemens, Samsung, they are working on software. Nobody is just doing assemblies on, doing soldering on the PCBs. So we need skilled people in electronics to work on certain softwares. And what engineering colleges, they train engineers that somebody will come and ask the question about how the capacitor works. Okay, how transistors works. That era, that physical understanding, conceptual understanding has to be present. But the era has moved to modules. Okay, you've seen students making final year projects, they connect 4 to 5 modules और ये उधर भी आगे गाड़ी भी चलाएगा, ऐसे ये डिटेक्ट कर लेगा कि कोई टक्कर होने वाली है, वो एक अल्ट्रासोनिक सेंसर और रिसीवर 300 रुपए का आता है, यहीं से खरीद के लाते हैं, उसको वहीं जोड़वा लेते हैं, वहीं पे 3-4 दुकानें हैं, वो वहीं जोड़ के बना के दे देते हैं, ठीक है? तो आप you can imagine what is the skills that are being required. Anyway, employability focus, so you should prepare the students for industrial 4.0 jobs. Now in research, advanced research area, AI manufacturing, digital twin, smart system. For teachers, I would suggest explore this part, digital twins. Choose a product, okay, which has some moving parts, okay, where predictive maintenance can be applied. Prepare digital twin in your college, in your lab. In your lab, go to mechanical engineering department. There is a lot of equipment lying idle. Okay, try to make them smart by connecting IoT devices. Just study the vibrations under production. Okay, and you can do wonders. Your students can get employed. Your department can get a lot of recognition. But just you have to do collaborate with 1 or 2 smart fellows from the CSE department and make a digital twin of a machine. That's all. Launch a small software or app in the market. It will be sold as a hot cake. Okay? Other companies will approach, please make a digital twin for my machine. Because there is always a machine, there is a manufacturer of the machine. Okay, you can directly contact to the machine manufacturer that I have made digital twin. This is a software, open it on your laptop and you can work. You can establish the center of excellence where you can do trainings to MSMEs, your students. Okay, you can train on any technologies, choose any one part. Startup incubation, you can incubate a startup, supporting student-led startups and innovation. Now, the government of India has also launched faculty startups. Okay, they are giving you seed money for as they used to give for students. Okay, so if you have some brilliant idea, some innovative idea, you apply in faculty startup. That would be supported by ATAL. Okay, the same way you have this ATAL FDP, AICT supports that. Okay, and in MSME, if your college has an impanelment, you have submit the idea gets okay, you submit the detailed projects, you'll get the funding, and then for production also this time Government of India is giving 50 lakhs rupees. So you build a prototype, then you want to go to give it to full production, so that is also available. Okay. In fact, we are lucky that IIT College Greater Noida has got this MSME empanelment, and we have been asked to give the proposals. Okay. So a faculty startup proposals can also be given. I mean, earlier people have this problem that अब स्टूडेंट स्टार्टअप होता है यार, फैकल्टी इतना आइडिया एक्सपीरियंस है, क्या करेंगे अपनी लाइफ में, अब तो हम कुछ नहीं कर सकते. तो इफ यू हैव सम स्टार्टअप आइडिया, यू गिव इट टू एमएसएमई डिपार्टमेंट एंड they will give the initial funding 35 lakhs if your project idea gets selected. Okay, so do your homework, then propose, write a project or some idea, and then you can go. As well as parallelly student का जितना scheme था, that is also there. उसमें कोई problem नहीं है government को. Government has encouraged this. Now collaborative research, joint project with industry and government. In India, in Lucknow, what do you have? Which industries you have? HCL, but HCL is big shot doing defense project. They would not entertain. HCL. Yeah, you have Scooters India. Local one. They need a lot of support. Go to Kanpur. Hundreds of industries are there. Just walk into any industry and I can make a predictive maintenance software for your company. They'll buy it. Clear? And one more industry is present in Lucknow. Okay? Can you name that? Huh? Not Tata Motors. Lucknow is the manufacturing hub of Sanmaika Industries. You know Sanmaika, this? Yeah. It is a hub of. You know, people manufacturing this Sanmaika board are supplying this to Gujarat, to various destinations. This is the biggest hub of Lucknow, and it is silently working. You go to that side behind Chowk. I worked with them for almost 1.5 years. I worked with them. Okay, I was actually working in biofuels. Okay, so I worked with them. So that is industries there, and it is very unorganized industry. No big names. They will not put on even a board that I am doing this. But inside that closed campus, they are doing it. So we have these industries, and one more industry was there in Lucknow, and unfortunately it shut down. And there were various vested reasons. Okay, there was some interest of the other countries also, and the name of that industry was UP Capacitance. Okay, they supplied capacitance to India's first satellite. Name the India's first satellite? Aryabhat. Okay. So we have AI is transforming how factories think, decide, and optimize. So we started with, if you remember the first slide, 5 parts. Okay. So this is summation, one line sentence, what they are doing. Predictive maintenance, AI-based quality control, process optimization, digital twins, and real-time analytics. You can pick any one part which is feasible for you and start working on that. Because India will become world's manufacturing hub. Okay? The government is putting a lot of effort. So this is AI in manufacturing. So we have predictive maintenance, process optimization, digital twins, real-time analytics, and AI-based quality control. So you can work on any part. Okay? For CSE, real-time analytics and AI-based quality control, digital twin, 3 parts are there. You can also work on predictive maintenance, process optimization, any part you want to choose. Okay, so AI transform data into intelligence, powering factories for the future. So robots are becoming smarter, adaptive and collaborative, moving from fixed automation, intelligent, to collaborative robots, autonomous mobile robots, vision guided robots, adaptive learning robots and flexible automation. If you have a team of mechanical, electrical and computer people, you can also start manufacturing robots, because what industry 4.0 needs? Lot of robots. Lot of technicians who can take care of robots which are already working in their industry. Lot of people who can do robot programming. Okay, I just not able to recall the name of the programming language, but you can work on that programming language. You can do patents. Okay, you can write codes, proprietary codes for those robots. Okay. So smart robotics, the future of work. Okay. So finally we will be having smart robots. So these are the 4 robots. Okay. So I will list it down all the use cases, and one thing is that, you know, everybody, well, in among the world, Indians are the most laziest people. They do not want to travel to vegetable market. They'll buy online. They do not want to go to grocery store. They do Flipkart, Big Basket, and no, what not. Okay, and the warehouse situation in India is pathetic. If you make any robot just for warehouse maintenance, you do warehouse robot programming, huge market is there, huge. Okay, because warehouse means there is a central Amazon warehouse from where every product will be shipped to entire city. You know, handling that amount of products, okay, is a challenging task. Okay, it's a very challenging, and that is why you see the Amazon, they work on very smart technologies, very high level of AIs. They adopt, learn very new technologies. And what they're doing? They're just shipping the product to the customer. Somebody else is manufacturing. Okay? Somebody else is manufacturing. You are paying for the product. Companies are ready to place the product in their warehouse. They are only managing the warehouse and logistics. And so such a huge big company nowadays. Okay, so we have smart robotics. You can work on computer vision also. Okay, BVD University has a very good lab for AI based labs are there. They've got good systems. Although the labs are busy because they have got same number of students also, but if you are there, you can have your some slot or some computers. You can it can be allocated, so you can work on the system. Clear? And you can work on computer visions. So future trends, 5.0 is coming. Okay, either be a part of it or you will be left out of it. Clear? So try to be a part of it. Okay, do not want to, means you shouldn't be embrace the change. Embrace the change. Accept that change is inevitable. It will happen. Okay, if you accept it, it's okay. If you don't, you will be discarded by the system. Clear? So shifting focus from automation to human-machine collaboration, that is the next step. Combines human creativity and machine efficiency. And now we will have in 5.0 human-centric AI. Okay, a lot of things will be there. Ethical, emotional, other kinds of AI technologies will be there. Okay. Now ethical issues are there. Yes, they will remain, because this is the only one positive side of the coin. The next side of the coin is that automation replaces humans. There would be a lot of job replacement and job displacement. So common in manufacturing, logistics and customer service. You know how many people are get employment by this Rapido, Ola, Uber? How many people are delivering groceries to your homes? You can't imagine in big cities. Okay? So people get employment also at the same time, but the job is at a very low level. Okay? But at least they can afford sustain themselves. Okay? It's okay that you can't expect them to take care of entire family, but they will be able to support themselves. So there is a job also. Concern loss of traditional jobs. Why the job displacement happens? Because increased use of robots, AI and automation tools. But businesses always aim for higher efficiency, AI systems and automation tools. Businessman is a greedy fellow. Okay? You want to take money from a businessman? Just show him that you can save 50 rupees. He is ready to accept your offer. He is not interested in your knowledge and your skill. You show him that in your factory, if you work like this, you can save 50 rupees in your product, on your production of your product. He is happy on that. Okay? So, business aims for higher efficiency, lower cost and faster production, so that he can sell more products. So data privacy is another issue. Production of personal and sensitive data. In AI system, large data is collected from sensors, devices and users. Okay, there could be a national TV debate today itself if some data is being asked by or leaked by the UDI, the Aadhaar or PAN card. Okay, but you are ready to wear a smartwatch from which is being manufactured in China, even though it is not a product of a standard company. Okay, and that I don't know, that smartwatch might be recording your voice also, your communication also, your every personal data also, but you are happy with that. So data privacy is always the issue with these kind of technologies. So because we work on sensor devices and user concerns, misuse or unauthorized access. Okay, once you are on the Android, you buy Android, you install the software, you download an app says access to your login through your Gmail. You say yes, you say it needs access to your location, you allow, because you want to work with that app, you need that app. Allow, want to take control of your message, allowed. And at the end, you are crying that my data is being lost. Have you ever, how many of you see reels? Most of you them must be in your free time, browse some reels. How many of you? The students, I'm concerned with faculty. Okay, you are faculty. So have you seen, just suppose today you see certain shorts on YouTube. After 3-4 days, the same short appears in your family. How they come to know? That you saw this ad, you saw this short video on YouTube, they know that you are connected to this fellow. And if you share the same interest as this fellow is there, it's a part of a family, so same line of thinking would be present. And there is an algorithm this YouTube also uses. Facebook even analyzes the patterns, who is connected to whom. Okay, one person who they can identify who is the lead person. Okay, who's very active in social media, wishing happy birthday, marriage anniversary to everybody. Okay, and you see the same kind of video start appearing to the entire world. So this is what? A breach of data privacy. I'm interested in certain kind of video. Why should my family member, you should propose the same or serve the same kind of video? And it doesn't even differentiate that, okay, father is watching the same video, mother is watching the same video, the same video appear with on the phone, Android phone of daughter and son also. Okay, so we came to know, means the reverse side is that you can observe, keep an eye what kind of video your family is watching. Okay, so that is all. So data concern is there. Smart factory and AI collects employees data, machine data, and behavioral patterns. Okay. So key takeaways are: integration is the key, data drives decisions, and change, it's a misprint, it's change is inevitable. Okay. So that is the culmination of this FDP session. And I've tried to cover the industry 4.0. I explained in the common relevant terms, kept the things very simple, and robotics also. Okay? So I hope that it has given you a very good outline and understanding of what industry 4.0 is, what industry 3.0 is, what is industry 1.0 is, and what industry 5.0 will be. Okay? Thank you very much. I'm done from my side. Any questions or relevant discussions from the audience? You want to clarify some things, some points? I'm open to it. I think most of you were unattentive this time. No? Because if a class doesn't have a question, that means either it bounced off, or it was nobody was interested, or it was too obvious for you. Okay? Yes, please.
Sir, what will be the major feature of Industry 5.0?
Yeah. See, AI is just in initial phase. Okay. We actually are, we think that AI depends, well, we depend on AI. The next revolution will be, the AI will be there, it will be always for your assistance, for your help. So that would be human-centric AI. The AI which we are seeing right now is not human-centric. It's not human-centric. So you have a ChatGPT, everybody uses, every student uses. ChatGPT doesn't tell the student that you are weak in mathematics. And inside the mathematics, you are weak in linear algebra. So because that is not human-centric, that is not customized. Now the next phase would be, there would be a teacher, there would be a school, there would be a student, and there would be a student-centric AI that will continuously guide. You give the Android phone to the student of class 4, 6, he is watching videos, games, he is playing game. AI-centric AI inside the Android phone will tell you that, or will guide unconsciously that student towards studies. Okay, so that era will come. Okay, so one is human-centric AI, and other would be collaborative robotics. Clear? So you better, what happens today is we understand how the robot is functioning, how the robot should actually help us out. Now the next level, robot will try to understand how can I help a human. Okay, there will be more robots in a human. Now Android is there, so we will have Android robots. Very soon we will have Android robots doing small, mundane, repetitive tasks. Like what we do, we clean our floors daily, so we should have some automatic robot that do cleaning for us. Okay, at least the area which is open, which is easily accessible, okay, that is being swept and kept neat and clean, tidy. So that kind of two things would be there. Okay, and of course there would be some disruptive changes also in Industry 5.0, because you have to adopt to the change. Clear? Or you will be left out. So that is the things that will happen in 5.0. Any more question?
सर अटल में जो भी आप बता रहे थे, अटल में फैकल्टी के लिए भी ये ऑप्शन है,
हाँ,
वो प्रोजेक्ट्स के ऊपर काम कर सकता है, तो क्या क्राइटेरिया होता है सर, कैसे काम कर सकता है?
Means the best one is that start with MSME. They are more open. So your college should be impaneled in MSME.
अगर केस नहीं है,
then your proposal will be 95% rejected, 99% rejected. Or else. It is extraordinary idea is there. ठीक, okay? तब तो वो accept हो जाएगा. Or else they entertain only impaneled institutes. They'll get the fair chance. Okay? Your institute got this Atal FTP. Now it is easy for them to get the FDP again. Next year we'll see again an FDP because they have this habit, है ना? जिसको मिल रहा है, जो कर रहा है, सब कुछ प्रॉपर है, डॉक्यूमेंटेशन प्रॉपर, तभी तो दूसरा मिला. अगर पहले वाले का नहीं मिला होता तो फिर क्या होता? तो गवर्नमेंट हैज लिमिटेड फंड्स, तो वो इम्पैनलमेंट कराते हैं, तो वो देखते हैं कि आपके पास क्या क्या है, क्या क्या नहीं है, आप कर सकते हो कि नहीं कर सकते, और वो सारी चीजें आपका कॉलेज डिस्क्लोज करता है जब आप इम्पैनलमेंट करवाते हैं. ठीक है, तो आप जब इंस्पेक्शन कराते हैं या कहीं जाते हैं सबमिशन के लिए, तो वो जा देख लेता है, सब कुछ है, आपने कह दिया और आपके पास मशीनिंग की लैब ही नहीं है और आप कह रहे हो कि हमें ये प्रोडक्ट बनाना है.
सर जो इस तरह की गवर्नमेंट स्कीम्स होती है ना एमएसएमई के प्रमोट करने के लिए, एक्चुअली क्या वो थ्योरी में तो बड़ी अच्छी लगती है कि बड़ा अच्छा है, गवर्नमेंट 15 लाख दे रही
जी.
इन फैक्ट क्या होता है कि जो जेन्युइन जो टैलेंटेड लोग ऐसा करना चाहते हैं ना, तो उनको प्रोसीजर के बारे में नॉलेज नहीं होती है. प्रोसीजर जो मिडिल मैन होते हैं ना, डाउट्स, इनको प्रोसीजर ज़्यादा पता होता है. उसमें क्या होता है, वहाँ पे कॉल्यूजन होता है डाउट्स और जो एजेंसी होती है गवर्नमेंट की, एक्चुअली जो एक्चुअल बेनिफिशरी होता है वो तो मतलब उसको अगर 15 लाख मिलना था तो पता चला मिला 5 लाख है, और बाकी सब मतलब ये होता ही है, आप पैसे वो लोग खा जाते हैं. लेकिन थ्योरी बड़ी अच्छी लगती है कि एमएसएमई के प्रमोट के लिए ये स्कीम है, वो सारे वो नेता लोग ही सब और जो दलाल लोग हैं ना वही सब खा जाते हैं पैसे.
I got your point. I mean you are drawing lot of experience from this is वो एक गांधी जी का एक स्कीम चलता था, वो खादी बोर्ड, तो वो 35 से 50 लाख रुपए तक का देते थे एमएसएमई को. जैसे आपको साबुन की मैन्युफैक्चरिंग करनी है, आपको राइस प्लांट डालना है, आपको कुछ प्रोडक्ट बनाना है, जैसे आपको पापड़ बनाने हैं, आपको अपने एक फैक्ट्री सेटअप करना चाहिए, तो खादी ग्राम उद्योग बोर्ड जो है वो आपको देता था. तो प्रॉब्लम क्या थी कि वो पूरा स्कीम का जो सेटअप और डिजाइन में बहुत सारी चीजें हुई हैं ऐसी, जिसकी वजह से ऐसा इंप्रेशन गया कि यार ये तो उन्हीं लोग का है कि वो आए, पैसा लिया, खाए और चले गए. बट ऐसा अब नहीं है. अगर आपका आइडिया में दम है, देखो आप आइडिया में दम है, देखो फॉर एग्जाम्पल इफ यू अगेन अप्रोच टू खादी ग्राम उद्योग बोर्ड कि मेरे को राइस फ्लोर का मिल डालना है, 50 लाख की फंडिंग करनी है, वो सब अप्रूव करा दोगे आप, वहां से अप्रूवल हो जाएगा, मगर नो बैंक विल गिव यू दैट.
अप्रूवल भी ऐसा नहीं होता, जब वहाँ के लोग डिपार्टमेंट के लोग पैसा खा नहीं लेंगे आपसे तब तक अप्रूवल ही नहीं देंगे. अप्रूवल दे देंगे तो बाद में जो सप्लायर्स वगैरह हैं तो ये सब पैसे खा जाएंगे, वो डायरेक्ट पेमेंट होगा.
I'm getting this point. But देखिए मैं आपको बताऊं सिंपल, वी आर रिकॉर्डिंग दिस सेशन, तो मैं कुछ अपना लैंग्वेज बैरियर है उसको बचा के बोल रहा हूँ. We shouldn't talk about dalals and those kind of things. प्रॉब्लम ये है कि अगर आपने पास करा, मेरी बात रिप्लाई सुनिए सर, आपने पास करा लिया यानी फिर आप जब बैंक के पास तो बैंक इतना लूट चुका है कि उसको पता है यार इसमें क्या होगा, कुछ नहीं होगा. आपके चेहरे पे, मेरे चेहरे पे लिखा है कि मैं चोर हूं, नहीं, आपके पे नहीं. तो बैंक का एक डेटा सेट होता है, एक डेटा बेस है, उसके डेटा बेस में जितने भी फ्लोर मिल, आटा मिल, चावल मिल, दाल मिल, वो सब लुट गए. मतलब बैंक के पैसे लगे, बैंक ने दिए क्योंकि गांधी बोर्ड ने उसको एश्योरेंस दिया था, वो भी पे, सब्सिडी भी दी गवर्नमेंट ने, सब्सिडी भी. और ये सारी स्कीम्स पहले क्या होता था, केवल और केवल पॉलिटिकली यू नो उन लोग को मिलता था जो पॉलिटिकल टच में होते थे, उन्हीं को स्कीम मिलती थी, वही खाए, वही स्कॉर्पियो से घूमने, सफारी चलाते थे, फिर वैसे. लेकिन अब ऐसा नहीं है. अगर आपका आइडिया अच्छा है, क्योंकि अब प्लेटफॉर्म थोड़ा ओपन है, प्लेटफॉर्म थोड़ा, मैं ये नहीं कह सकती ऐसा आज भी नहीं होता या नहीं होगा, हो सकता होगा, आई डोंट नो, बट नाउ द थिंग्स आर ओपन. आप पूछ सकते हो आरटीआई डाल के, भैया मेरा प्रपोजल क्यों रिजेक्ट कर दिया. Did anybody in this room have this guts to ask this कि under what grounds आपने disqualify किया? And for that I think अगर किसी को ऐसा है, you know what about एक कार आई थी डेबू मोटर्स बनाती थी,
मटीज,
हाँ मटीज बनाती थी, और एक और बड़ी से बड़ी अच्छी सी कार मटीज. दैट फेलो वो बिलोंग किसको करती थी पता है, कंपनी साउथ कोरिया में.
नहीं साउथ कोरिया
नहीं, वो डेबू मोटर्स एक्चुअली थी साउथ कोरिया की. एक इंडिया का आदमी उसको खरीदना चाहता था, पूरी फैक्ट्री और वो गया बैंक के पास, रिजेक्ट, ये कमी है तुम्हारे पास। नेक्स्ट टाइम प्रपोजल में रिमूव करके गया, एक ही पॉइंट कमी, एक ही पॉइंट रिमूवल, एक ही टाइम उसने इम्प्रूव किया, रिजेक्ट। 49 टाइम्स उसका प्रपोजल रिजेक्ट हुआ। एंड में इतना परेशान हो गए बैंक वालों ने, कह भैया ये रहे जीएम, तुम सामने हमने बैठ के बात करो। ठीक है, उसने कहा क्या हुआ, उसने कहा कि आई एम वेटिंग फॉर योर रिजेक्शन, देन आई विल कम बैक इम्प्रूव करके। तो उसने कहा यार योर सच काइंड ऑफ डिटरमिनेंट हैज टू ग्रांटेड, चलो वो खरीद लाया फिर यहाँ पे। वो एक अलग बात है, वो फेल हो गया जो भी है, लेकिन बैंक ने उसको 49-50 टाइम पे दिया। तो इफ यू आर एक्चुअली वेरी कंसर्न विद योर पैशन, विद योर, तो आप कर सकते हो, कहने का मतलब ये। और अगर आप सोचो कि कुछ नहीं हो सकता, अब हम रोड के कचड़े को उस साइड देख के, रोड के इस साइड खड़े होके स्वच्छ भारत अभियान को गाली दे रहे हैं, है ना। आपके पास गट्स नहीं है कि आप झाड़ू लगा के वहां पहुंच पाओ। अरे क्या होगा, कुछ नहीं होगा, आज हटाओगे कल फिर डाला जाएगा, ये पड़ोसी नहीं सुनता। या आपने कभी उठाने की कोशिश की, एक प्लास्टिक उठाई अपनी जमीन से, किसी ने नहीं उठाई। और आपका एनालिसिस इतना तगड़ा है कि आप चाय की दुकान से लेके फ्लाइट में बैठ के कुछ नहीं होगा। तो भाई कभी जो किया ही नहीं तो होगा कैसे? आप बताओ, हाउ मेनी ऑफ यू पार्टिसिपेटेड इन स्वच्छ भारत? आपकी गोमती है, आप वहां पे गए किनारे पे, जिसने उसमें से वो वाटर हाइसेंथ निकाल के बाहर रख दिया हो, 1 किलो निकाली, किसी नहीं निकाली। और उल्टा जो 4-5 लोग निकालने पहुंचते हैं तो बेवकूफ है यार, बेवकूफ आदमी पहुंच गया वहां पे। तो यार आप करना नहीं चाहते, आप क्रिटिसाइज कर दो, तो हमारी पूरा सोसाइटी का एक पैटर्न बन गया, एक ऐसा इम्प्रूवमेंट। वही हमारे बच्चों के पास हो जाता है, चाहे खुद का बच्चा हो, पड़ोसी का हो, चाहे स्टूडेंट। अरे क्या है, उसमें चक्कर में पढ़ो, इधर पढ़ लो, फायदा हो जाओगे। और आप वेस्ट में देखो, जितने फेल है वो सब कंपनी लिए बैठे हैं। स्कूल नहीं गया बिल गेट्स, जुकरबर्ग नहीं गया, हाँ, सब जॉब आदि छोड़ के भाग गए और सब बड़ी बड़ी कंपनीज, वो बड़े बड़े स्टार्टअप बना लिए। हमारे यहाँ पढ़े लिखे नहीं बना पाते, हमारे यहाँ पढ़े लिखे नहीं बना पा रहे। तो आप बताइए हम पीछे गए हैं, हम पीछे गए हैं माइंड सेट। सिर्फ माइंड सेट ही तो हमको रोकता है।
सर जितने ऐसे सक्सेसफुल लोग हुए हैं, जैसे जुकरबर्ग या कोई भी इंडस्ट्रीज हुए हैं, तो उन्होंने वो किसी गवर्नमेंट की फंडिंग से नहीं आगे बने हैं, वो अपने वो लोअर लेवल से बेसिक से काम करके।
अच्छा, मैं आपको अपना एक्सपीरियंस बताता हूँ।
बैंक से लोन लेके कोई आदमी मतलब बड़ा
बहुत बढ़िया। इस सीडी का जमाना था, तो सीडी क्या था, मूवीज की सीडी आती थी, तो आपने देखी वो रेंट भी होती, मतलब आप सीडी लाइब्रेरी में जाते थे, रेंट था मूवी, और वो मूवी में सेंडलिंग करते थे, सीडी खराब हो जाती थी, फिर अगेन उस सीडी वाला सीडी लाता था, उसकी कॉपी बनाता था। तो बेसिकली सीडी का कंजम्पशन बहुत आया। आई वांटेड टू डू बिजनेस विद दैट। अब देखो यहाँ से बहुत ध्यान से सुनो, वेस्ट में क्या होता है आज भी, यू कैन ओपन बिजनेस ऑन अ कॉफी टेबल। 4 आदमी ने कमिटमेंट किया, हाँ ये बनाओगे तो मैं ले लूँगा, ये लाओगे तो मैं ले लूँगा। मैंने भी 4 आदमी उस कमिटमेंट ले लिया, क्योंकि मैं भी थ्योरेटिकल आदमी था, ले लिया कमिटमेंट। मेरा मुझे कितने रुपये पड़ती है, उसको मुझे 7 रुपये पड़ती है। तो मैंने ठीक है, मैंने कहीं जाके 6.5 रुपये डील कर लिया। मैंने कहा 50 पैसे तो मुझे बचेंगे, इतना कंजम्पशन था लखनऊ में। मैं अच्छा थोड़ा सा ये था कि गॉड्स ग्रेस मैंने बहुत पैसा नहीं इन्वेस्ट किया, मैंने छोटा पैसा इन्वेस्ट किया। मैंने कहा इसको टेस्ट करते हैं, तो 5000 रुपये का इतना बड़ा बॉक्स ले आया सीडी। मैं उसके बाद पहुँचा, मैंने कहा भाई तूने कहा था 7 रुपये में ले लेगा तू? कह रहा मुझे तो इससे भी सस्ती पड़ती है। आप सुनो, इससे सस्ती पड़ी, व्हाट डू यू मीन? कह रहा है यार मुझको 5.5 रुपये में पड़ती है। अब मैं बड़ा परेशान, मेरे इतने सारे पैसे फंस गए, मैं बहुत यंग था। तो मैंने कहा क्या करूँ। आई वेंट बैक टू अदर, जिससे मैंने सीडी खरीदी थी, मैंने उसका प्रॉब्लम, मैंने कहा अंकल जी ये तो बड़ी प्रॉब्लम हो गई मेरे साथ। मैंने वहाँ पे बोला और उसने कहा इतने में, मैंने आपसे आपको इतने में लूँगा, डिफरेंस मेरा होगा। तो उसने बहुत एक्सपीरियंस था, ये कोई नाका इंडोला की बात है। तो पता नहीं क्या उसने मेरे अंदर देखा, और वो नाका इंडोला से अलीगंज आया, मैं अलीगंज में रहता था, और एक बरसात ऐसे वाला मौसम था, खूब बारिश हो रही थी। फिर बारिश रुकी और लिटरली स्ट्रीट्स वर एक्चुअली विद नो पीपल, और मैं रात में 9 बजे उसका इंतज़ार कर रहा था। वो आया और उसने मुझसे बात की, और उसने मुझसे जाते क्या कहा, बेटा इंडिया में बिजनेस करना है तो पहली कलम, मतलब पहला जो इन्वेस्टमेंट होता है उसे डुबोना ही पड़ता है। वो तुम्हारे साथ खेल गया। अब वो क्या चाह रहा है, तुम्हारे 7,000 रुपये में वो 1,500 रुपये का जो तुम मुझसे मार्जिन कमाते, वो तुमसे 1,500 रुपये का फायदा कमा रहा है। उसने कह दिया, क्योंकि मैंने क्या किया, मार्केट सर्वे नहीं किया। अब बट आई लर्न फ्रॉम, मगर वेस्ट में क्या होता है, अभी भी वो उन्होंने कह दिया हाँ आई विल बाय एट दिस रेट, वो थोड़ा ऑनेस्ट। हमारे यहाँ लोग बहुत चतुर होते हैं, हाँ समझ रहे हो, मतलब नहीं मैम चेंज नहीं, अरे आप अबे एक तो हम लोग जब सुबह उठते हैं शीशे में, तो ऐसा कोई आदमी नहीं हुआ दुनिया में, मतलब इस रूम में, जो अपने आप को सुपर डुपर इंटेलिजेंट ना समझता। कोई है बिल्कुल समझता? वो यही समझता है कि भैया मुझसे बड़ा तो कोई पैदा नहीं हुआ ना होगा। ठीक है, अब ऐसे लोगों से तुम डील कर लो। अरे और तो छोड़ो, मैं तो यूनिवर्सिटीज में कोलैबोरेटिव प्रोजेक्ट हाँ सब कुछ चलता रहा। एंड में जब मेन एग्जीक्यूशन टाइम आई तो मैं रामा यूनिवर्सिटी बताता हूँ, एचओडी मैकेनिकल और सवाल नंबर बैठा ना भाई सर मेरा लेक्चर है। मैंने कहा यार मैं पूरे 1 हफ्ते तुम्हारे टाइम के लिए बैठा, तुम यहाँ पे बैठ कर कुछ करोगे और तुम जो है वो कह रहे मेरा लेक्चर है। और करना कुछ नहीं था, एसिटिलीन से एक एसिटिलीन गैस होती है जिसकी कैलोरीफिक वैल्यू नेक्स्ट टू हाइड्रोजन होती है। उससे अगर कार चलाओगे तो प्रॉब्लम क्या होता है कि कार का जो पिस्टन है ओवर हीट हो जाता है, इंजन ओवर हीट हो जाता है। तो या तो कूलिंग सिस्टम बहुत अच्छा हो, या पिस्टन का साइज इतना बड़ा कर दो। तो पिस्टन मॉडिफिकेशन करना था। मैं भी काफ़ी मैकेनिकल इंजीनियरिंग पढ़ के गया, लेकिन एंड में जब एग्जीक्यूशन की बात आई तो उसने हाथ खड़े कर दिए। यार क्या चक्करों पड़ा यार, वो कार वहाँ बनी, चली, और चली कितनी जाते यहाँ से, जैसे खैर वो तो थोड़ी यूनिवर्सिटी बड़ी है। आपका जो डिग्री, ये डिग्री कॉलेज है, इंटर कॉलेज के 2 बार आए गई, वो इंजन गर्म हो गया, रेडिएटर बता तो बस फट जाऊंगा मैं, बंद कर दी गई। फोटो सेशन हो गया, एसिटिलीन से कार हो गई।
सर एक बात और है सर, एक आपका 2 मिठाई लेंगे। एक्चुअली आपने जो अपनी स्कीम बताई ना एमएसएमई की, तो जो यंग लोग है ना, जो जेन्युइन इंडस्ट्रियलिस्ट है या इसकी फैमिली का आदमी है, तो क्या करता है राइट फ्रॉम द फर्स्ट डे पहले वो मेहनत करता है, फिर वो धीमे धीमे ग्राउंड लेवल से राइज करता है। बड़ा जैसे अच्छा हम लोग क्या करते हैं, स्कीम देखी गवर्नमेंट की 15 लाख रुपए मिलेगा, और वो हम लोग चाहते हैं कि पहले दिन से मेरे पास एक केबिन होगा, टेलीफोन होगा, 10 नौकर होंगे, और मैं ऑर्डर करूँगा, पर करना होगा कुछ नहीं, खाली और नौकर लोग ही कम भट्टा बैठा देते हैं बिजनेस का। मतलब वो कहा कि पहले दिन से मेरे पास बढ़िया गाड़ी होगी मर्सिडीज की, राइट फ्रॉम द फर्स्ट डे। और जो जमीन अगर बिजनेस में अगर बेटा है तो पहले दिन तो खून पसीने में पहले वो फुटपाथ पे काम करेगा, फुटपाथ पे दुकान खोलेगा, दुकान से 1 दुकान से 4 दुकान होगी, 4 दुकान में 30 दुकानें होंगी। तो जमीन जो इंडस्ट्रियलिस्ट और बिजनेसमैन है एक्चुअल में वो ग्राउंड लेवल से शुरू करते हैं। कहना वो ग्राउंड लेवल से शुरू करते हैं, यहाँ से संघर्ष करते हैं, यहाँ से साइन करते हैं। हम लोग क्या करते हैं, सीधे साइनिंग पॉइंट से स्टार्ट करना चाहते हैं कि पहले से बढ़िया जलवा होगा, बढ़िया नौकर होंगे, बढ़िया टेलीफोन करेंगे, 4 लोग गाड़ी होगी बढ़िया। तो दैट इज द प्रॉब्लम में। हाँ, ग्राउंड लेवल से शुरू करना चाहते हो, साइनिंग लेवल से स्टार्ट करना।
हाँ, हम चाहते ही हैं हमारा स्टूडेंट जो है पास आउट होता है, वो चाहता है मेरे पास सीधे टीसीएस का एक बैच हो, ठीक है, मैं एसी केबिन में बैठूं और मेरा जो सैलरी पैकेज हो कम से कम मतलब 12 लाख का हो, और खुद जो है कभी एक इवेंट का प्रोग्राम नहीं बना, ठीक है, खुद और उसका एक्सपेक्टेशन इतना है।
अगर फादर रिटायर हो गए, 15 लाख उनके फंड ले लिया, अब 10 लाख ससुराल से ले लिया, और थोड़ा 10 लाख लोन ले लिया, और पूरा 50 लाख भट्टा बैठा दिया। पहले दिन से वो एसी गाड़ी हो, ये नौकर हो, ये वो नौकर, ऐसा भट्टा बैठा के बाद पता चला कि वो कोई प्राइवेट जॉब अगले दिन से।
एक्चुअली हम किसी सक्सेसफुल आदमी के पीछे की वो स्ट्रगल नहीं देखते, हमें उसके वो तो देखते हैं। आपने अक्सर सुना होगा बिजनेस जो करते हैं बच्चे जो यंग एज वाले होते हैं, वो कहते हैं पैसा पैसे के लिए काम करता है। ये सुना होगा आपने लाइन यूट्यूब पे अक्सर कि आप इन्वेस्टमेंट करिए, है ना, इन्वेस्टमेंट करिए, 10 रुपए लगाएंगे तो आज लगा दिए तो आप 50,000 करोड़ हो जाते, ठीक है। पैसा पैसे के लिए काम करता है, एक एज के आने के बाद, एक सक्सेस होने के बाद करता है, पहले नहीं करता।
सही बात।
तो हम उसकी वो सक्सेस के पीछे का जो पेन और इफर्ट है वो कभी नहीं। Agree?
सही बात। आप आपने बहुत सही बात की कि हम लोग कई समझ नहीं सकते।
Thank you so much, sir. It was wonderful engaging session on Industry 4.0, smart factories and robotics, and also a wonderful head start, conceptual head start for Industry 5.0. Sir, सहमत हैं? Right. Your expert guidance and practical insights covering the evolution from Industry 1.0 to Industry 4.0 greatly enriched participants, and I think all the participants were very much engaged in the session. I request Dr. Vijay Srivastava, Head Faculty of Management Studies, and Mr. Mahesh sir from Computer Science Department to present a certificate of our sincere appreciation to our lecturer.
सर आगे आ जाइए।
एक सेकंड क्योंकि लाइट चली गई है तो यहाँ पर आ गया ना बैकग्राउंड में वो आ जाएगा। हमारे इलेक्ट्रॉनिक बैग में
I request Dr. Shali Ramba, Head Department of Computer Science, to please stand up vote of thanks. Thank you.
Very good afternoon to one and all present here. So once again, day 3, we have session 1. I thank sir for his innovative session. So we are at the end of session 1 of day 3, and we are now heading towards the article discussion. Today the lecture that was given by sir, as usual, because we had a wonderful experience with him in the basic ATAL FDP, which was conducted, and we had called sir for one of the sessions. And since he makes his lecture so simple and understandable, which can easily be comprehended by everyone, because we have participants from diverse fields, so it is for this reason we chose sir this time also. And thank you so much sir once again for this session, and thank you for your time. He's travelled all the way to Lucknow to deliver the session. So I take this opportunity to thank his better half. She's also here accompanying him. So thank you ma'am for your time as well. I request all the participants now to please head towards your respective tables for the article discussion. Thank you very much and have a wonderful day. Thank you. Please participants come for the group photograph first, then you head towards your tables.